You open Netflix, you click play, and in less than 3 seconds, video starts. No buffering, perfect quality. But think about this for a second. At that exact moment, 200 million plus people are watching Netflix simultaneously. And the important thing is all streaming different videos all over the world. Some are watching science fiction, nature, news, family, crime, comedy, action, history, whatever. Look at the numbers. Global concurrent viewers 200 million plus. Okay, all streaming unique content, stream quality 100% perfect. Like, how is that even possible? Buffering 0%. How's that even possible? It's a magic or what? Plus, the second question is, how does Netflix store, our Netflix store thousands of movies? Third question is, how does it stream to millions of people at the same time without crashing? So this is not a magic, this is pure engineering, and today in this video we are going to build it from scratch using Spring Boot plus Apache Kafka plus Amazon S3 plus Redis and other databases. Okay, without wasting much time, let's proceed. Let's go. Okay, let's understand the real problem first. Pay attention here. Imagine you upload a movie to Netflix. Okay, so imagine you upload a movie to Netflix. Yeah, okay, and that movie is 2 hours long. Okay, and raw file size is, let's say, 50 GB. Okay, got the scenario? So imagine you upload a movie to Netflix. That movie is 2 hours long and raw file size is 50 GB. Now 10 million. Look at the numbers. 10 million people want to watch it simultaneously. Yeah, okay. 10 million people want to watch it simultaneously. Different devices. Yeah, on different devices possible. So maybe on mobile phones, okay, on laptop, on TV. Yeah, and different internet speed, the quality comes into the picture. Okay, so some are using 5G, some are 4G, some are fiber. Possible? Okay, 3 massive problem, that is SSQ. Okay, what are these? Let's see. Fine. So the problem is SSQ. Okay, so the first S means storage, streaming, and Q means quality. 3 most serious problem. Let's take one by one. Storage. So you can't store the 50 GB raw file and serve it directly. Why? Because it would cost you millions and literally kill your servers. This is just 150 GB. There are many. We can't serve it directly. Definitely kill your servers. Second, streaming. Now, how will stream this? Okay, suppose you uploaded a file on Netflix. Okay, and the file size is 50 GB, and viewers wants to watch it simultaneously. How this streaming concept comes into the picture? Like if I'll ask you design it, so the very first thing we'll get in our head, that is, okay, I have uploaded a 50 GB file. Now user wants to watch it. So first thing is user can download and then watch. Okay, but streaming is not the download thing. User need to watch it immediately clicked, like you open Netflix, click on the play and video starts. Not like first downloading 50 GB and then. So streaming is the problem. Stream. Third problem, that is quality. Okay, so a person watching on 4G will not get the same quality on fiber or on 5G. Yes, so video needs to adapt it automatically. And Netflix solves all three problems with one powerful concept that we are going to build today in this video. Okay, understood the problem? Like storage, we can't store the 50 GB raw file and serve it directly. Streaming is the problem. User need to watch it immediately, not after downloading 50 GB. And quality, 5G, 4G, fiber need to adapt automatically. And here comes our Netflix, the boss, solves everything. Okay, so we'll build it. Okay, in this video we'll build our Netflix and we'll see like how this all problem solved. Like we can able to stream, the quality and the storage problem also get solved. Okay, so let's move to our next section, that is HLD, high level design architecture. Okay, and then HLS, HTTP live streaming, the technology behind Netflix, YouTube and every streaming platform. So I'll explain that too and then we'll code it. Okay, so yeah, let's proceed further. Let's go. Okay, let's understand the high level design architecture. Okay, so let me just draw. Please pay attention and all your focus on my screen. Okay, here. So this is what our video and this is what our live streaming service. Yeah, okay, so first is API gateway and content service. So this is our movie catalog. Okay, and this is our video service. Okay, so uploading plus S3, upload plus S3. Okay, and this is what our streaming service. Okay, HLS, HTTP live streaming, HLS playback. Okay, then 1 second. So okay, and yeah, then Kafka. Okay, Kafka topic, let's say video dot uploaded. Okay, and then what? Yeah, encoding service. Okay, so here is our important part, encoding service. Fine, like how Netflix immediately starts the video. Suppose today I want to watch some movie on the Netflix, so I just click on the play and how Netflix immediately start that video. Like there is one scenario, I need to download it, the other is video is streaming and I'm watching it, and also on the good quality. Plus if my internet goes down, then the quality automatically shifted from 1080 pixel to let's say 480 pixel. Yeah, it happens, right? Yeah, so everything I'm gonna explain you how it happens and why it is happening. So that's why I told you, please all your focus should be on my screen. Okay, fine. So let me just okay, yeah, encoding service, FF. Okay, yeah, FFmpeg, FFmpeg. Okay, and then Okay, so let me okay, and here comes our AWS. Okay, fine, quite. So AWS S3, right? AWS S3, it is a video storage. Okay, let me just go one by one. Okay, fine. So the first is API gateway. We all know that it is a single point entry. Okay, all request comes through here. All request comes through here. Okay, fine. Our next service, that is content service. So it is a movie catalog, like stores movie title, description, genre, and thumbnail, URL. Okay, think of it like a database DB of all Netflix content. Okay, think of it like a database of all Netflix content service. Next comes the video service. Okay, so it handles the upload video. Okay, it handles upload video, like suppose Netflix add a new movie, so video service receives a raw video file. It receives a raw video file and uploads it to AWS S3. That's why I wrote here upload plus S3. Understood? Okay, next is encoding service. So video uploaded and then encoding. This is the secret weapon. Okay, I want all of your focus to be here. Okay, it does two important things. So encoding service, yeah, pay attention here. So once video is uploaded, number one, it converts it into multiple, okay, one second, it converts it into multiple qualities. Okay, so 360 pixel, 480 and 720, 1080 and so on. Second most important thing, any guesses? Okay, fine, leave it. Second most important, that is it converts it into HLS format. HLS, HTTP live streaming. This HLS, what it means, and why you have created another separate section to explain this. Okay, let me just tell you the definition or what it means. It means small chunks of 10 seconds each. Okay, now you might be thinking, now we are getting something. You mean to say the entire 50 GB file, 2 hours long, converted into small chunks, like a small video of 10 seconds each. Yes or no? Yes. Okay, so now we are getting how Netflix stream a video. Okay, don't worry. There is a separate section I have created for HTTP live streaming, HLS. After this, I'll explain it each and everything, what files it will create, which playlist, which master playlist it download, okay, and which chunks in which order needs to play first, everything. Okay, just first understand this. So HLS format, it means small chunks of 10 seconds each. Okay, small chunks of the video, 10 seconds each. So this is what our encoding service does. Once video is uploaded, so in the video service, then it converts into multiple qualities and HLS format. And this is what enables the smooth streaming on any device, any internet speed. Getting a point? Okay, our next service, that is the streaming service. So when you click play, then this service serves the video chunks from S3. Okay, it serves the video chunks from S3. Okay, yeah, definitely the chunks stored in the S3. Okay, and it decides which quality to serve based on your internet speed. Getting a point? Are you with me? Yes or no? If you with me, then you can subscribe my channel. Okay, fine, leave it. So this is what our all the 5 components. Yes, content service. Okay, movie catalog, it's like a database of all Netflix content. And then video service, upload. Okay, and then encoding service. So once the video is uploaded, it converts into multiple qualities. Okay, like how qualities, which qualities to pick, and in between, suppose video is running smoothly, and suddenly the quality changed from 1080 to 480. How it does? Okay, also everything I'm gonna explain in HLS format, HLS section, HTTP live streaming next section. Fine. And then it converts into HLS format, small chunks of 10 seconds each. Okay, and then the streaming service, so it serves the video chunks from S3 and decides which quality to serve based on your internet speed. Okay, yeah, and you can see connecting the video service to the encoding service via Kafka. Okay, why? Because see, once the video is uploaded, video service, video uploaded, then video service publishes the video uploaded event and encoding service consume that event. Yes or no? And start processing automatically, fully asynchronous. Okay, fine. So this is what our HLD architecture, high level design architecture. I hope you got each and every components of it. Now the next section is our HLS, HTTP live streaming. Okay, the technology behind Netflix, YouTube and every streaming platform, like how it does, how user can watch immediately, switching between qualities. Okay, instead of downloading an app. Fine, so let's go to our next section and then we'll start our coding part. Okay, fine, let's go. Okay, let's start. HLS stands for HTTP live streaming. Fine. Raw video file 50 GB and 2 hours long. So once the video is uploaded, okay, fine, pay attention, then PEG, okay, encoding, yeah, so we have seen this, yeah, this one, okay, encoding service. So I told you that it does 2 things. What it means in actual, like what it actually does. So okay, we have talked about the small chunks. Fine, very good. So let's say chunk1.ts TS files. Okay, similarly chunk2.ts. okay, chunk3.ts and till chunk n.ts. So these are the small chunks, a 10-second video file and equals to 2-hour long video. This complete. Okay, cuts into small chunks. This is what our service, encoding service, do. Now you might be thinking, okay, this is what we have discussed, that our encoding service convert it into HLS format, small 10-second video file. But you have also told us about this quality. Yeah, also encoding service does is it creates chunks for all the quality. Okay, let's see. This is of 1080 pixel. Like every video, so this is what, this is the video files. Chunk 1, 10-second video file is starting 0 0 to 0 10. Okay, the next chunk is the next part of the video. So 0 10 to 0 20. So 10 seconds till at the end, till 2 hours. So these all files, small chunks, are of 1080 pixel. Similarly for all the pixel, the next is, let's say, 720 pixel. It creates the same chunks, chunk 1.ts and till chunk n.ts file. But these video files are in the 720 pixels. Getting? Okay. Similarly, all the qualities, 480 pixel, 360 pixel. Okay, and same thing for this too. Yes or no? You know point? So this is the job of our encoding FFmpeg. Okay. Next thing is, and yeah, one more thing, all chunks stored in AWS S3. Okay, stored in AWS S3. Fine. Then what? Then a master playlist file is created by the name master.m3u8. Okay, one second. m3u8 by this name, a master playlist file created. So this file is like a table of contents. So what it does is, it tells the video player that here are all qualities available and here are all chunks for each quality. It tells our video player, here are all chunks for each quality. Okay, now when you click the play button, your player downloads this file, master.m3u8 file first playlist file. Okay, table of contents, obviously, like which chunks. Okay, need to decide. Yeah, and then it starts downloading chunks one by one. So if your internet speed is fast, then the 1080 pixel chunks gets downloaded and served. If slows down, then 720. But you might be thinking, one question, you explained it, fine, we got it. But now at the end you said that it starts downloading chunks one by one. Okay, so it is downloading. So to download the chunks, yeah, let's say the internet speed is fast, so it start downloading the 1080 pixel chunks. So definitely it will take time, because suppose there are suppose 1000 chunks for this video file. Okay, let's say whatever. So definitely to download all the chunks, okay, it will take time, 10 seconds. But in actual, when I clicks on the play, immediately or less than 3 seconds, in 1 second, 2 seconds, the video starts. Yeah, so it will not let you wait till it download all the chunks. Each chunks is about maximum 3 MB or 3 to 4 MB. Okay, so first it downloads the first chunk 1, video from 00 to till 10 seconds. It serves, video starts. While you are watching, it downloads the second one, then third one, then fourth, fifth, sixth, seventh, and till n, 1000. That is why our encoding service cuts the video file, whatever 2 or 3 or 4 or 5 or long movie, into small chunks of 10 seconds, so that I can download the 10 seconds with the good internet speed in just a fraction of seconds and serve it while you are watching. In the back end, the downloading is in the progress, chunks, like we'll never know that. And in between, suppose 1080, okay, so from 00 to 10 seconds, fine, great quality, till 20, great quality. And then if internet goes down, slows down, then automatically switches to 720. Yes, so everything happens in the backend. We'll never get to know this. Yeah, okay, so this is what our HTTP live streaming works. And this is called adaptive bitrate streaming, and this is what we are going to build it today in this video. We have understood the problem, and then we have seen the high level design architecture, okay, and then we have learned the HLS, HTTP live streaming, how streaming works. Now it's time for the coding part. Okay, so before we start any service, we need our infrastructure up and running. What that means, Redis, AWS S3, okay, we need to create the S3 bucket, fine, then IAM users, okay, we need to create the access key and secret, fine, then Apache Kafka, Zookeeper and MySQL, okay, yeah, so Redis and AWS, okay, then Apache Kafka, Zookeeper, okay, MySQL, okay, in that we need to create the S3 bucket, okay, we need to create user and then create the access keys. Okay, so remember this golden rule: before going into the Spring Boot, first we need our data flow infrastructure ready, up and running. Okay, golden rule, fine. So let's start. Okay, and for that, first let me go to my file explorer. Okay, I've already created one folder. In that we'll put all our microservices. Okay, so yeah, here I have one Docker Compose file. Okay, the link of this file I've already pasted in the description. You can just go there and download this file. Okay, in that there's nothing, all the services I have just added. So Redis, MySQL, okay, Zookeeper and Kafka. Okay, S3 will go to the Amazon AWS console and will set up there. Fine. So okay, so what I need, MySQL I already installed on my local machine, so I just need Redis, Kafka and Zookeeper. Okay, fine. So you can just go with the command prompt or bash. Okay, let me just open the bash here. Okay, same thing with the command prompt. Okay, and fine. So here you just need to run one command, docker compose -d. Okay, so I need just three things, right? Redis, okay, and Kafka and Zookeeper. Okay, so Redis, Kafka and Zookeeper, right? Okay, let me just hit enter, and yeah, can you see? So pulling three images, Redis, Zookeeper, Kafka. Fine. Okay, so once done, got pulled here and create the container. Yeah, one more thing, if you haven't downloaded the Docker desktop, please download it. Okay, if you don't know, the link is given in the description, the download link, go there and you can just download the Docker desktop. Okay, because we'll gonna run our all the data flow via Docker itself. Okay, so where is my bash? Okay, so let's wait for a few minutes. Okay, till it creates our container. Okay, and starts it. Fine, MySQL is already, I have installed on my local, so no need. Just three things, and the next is AWS. Okay, so we'll go to the aws.amazon.com console, and I'll show you how to create the S3 bucket. Okay, and then access key and how to get our access key and secret. Okay, let's wait for a few minutes. Okay, so all three got pulled. Fine, and yeah, can you see by the folder name Netflix, and all three up and running. So let me just go inside, and yeah, Redis, Zookeeper, Kafka. Okay, fine. So all three done. The fourth is my MySQL, already installed my local, so fine, up and running. The next is what? Our AWS S3. Okay, so for that, just focus on my screen. Okay, fine. Okay, so now open your browser and hit aws.amazon.com, right? aws.amazon.com. okay, so it brings us on the home page of AWS. Fine, now just click on this create account button, top right corner. Fine, and we will be redirected on the AWS sign up page. Okay, yeah, so what's saying us, look at this, try AWS at no cost for up to 6 months and start with $100 in AWS credits. Okay, so you will get $100 for sure, plus earn up to $100 by completing various activities. Okay, so I'll show you, there are 5 activities, $20 each. Okay, fine. So now sign up for the AWS. So signing up for the AWS is super simple. Okay, not a big task. You just need to provide your email address, okay, AWS account name, then verify your email address. Next step. Okay, so there are, I guess, total 5 steps. Okay, you need to just provide your password, add a card, and that's it. Okay, so I've already signed up. Let me log in. Meanwhile, you'll just do it along with me. Okay, so that we can set up our S3 bucket IAM users and create the access secret key simultaneously. Okay, along with me. Fine. Okay, so let me sign into my account. Okay, so I have successfully logged in, and here is our AWS console home page. Right, fine. So now let me show you one thing. Okay, yeah, so can you see the credits remaining here as $99.28. okay, so because I'm using some resources, so got charged. Fine, you'll get $100, and Also, let me scroll down. Yeah, here. Can you see this? Explore AWS activities 0 of 5 completed and credits earned $0 of $100. Okay, so there are total 5 activities, and the first is like launch an instance using EC2. Okay, $20. Use a foundation model in the Amazon Bedrock Playground, $20. Set up a cost budget. Create a web app using AWS Lambda and create an Aurora or RDS database, $20. Fine. Okay, leave it, no worries. Now let's set up our S3 bucket. Okay, let's create our S3 bucket, the first thing. Fine. So I hope you already logged in, okay, and you are doing along with me. Okay, so just on the search bar type S3, okay, and click on this, the first S3 bucket link. Okay, and let's wait for a few seconds. Okay, yeah, can you see this create bucket button? Just click on that, and here. So at first let me just take this. Yeah, now I want you to focus on this part, that is AWS region. Okay, for me it is Europe, Stockholm, EU. Okay, one second. Europe, EU hyphen north hyphen 1. Okay, so you can note it down because we need the AWS region in multiple places once we start coding our encoding microservice and streaming microservice. Okay, fine. Next is bucket namespace. So just select the another one, that is account regional namespace. Okay, also AWS recommends it. Fine, and it adds the extra security. Okay, AWS adds the unique suffix to our bucket name. Okay, and nobody else creates the bucket with the same name, right? Okay, so now the next is the bucket name, and it is asking me to enter the bucket name prefix. So let's add Netflix is streaming and videos. Okay, yeah, so this is what our bucket name prefix, and the suffix automatically generated. Okay, a unique. Fine, so my full bucket name is Netflix streaming video. Okay, prefix suffix. Okay, this is the region, right? Scroll down. Yeah, this one is important. Please do not uncheck this. Okay, can you see the Amazon is giving us warning? Turning off block all public access might result in the bucket and the objects within becoming public. So keep this remain checked. It means our videos are completely private on S3, and users can only access the videos through our streaming service, which generates pre-signed URL. And this is how Netflix protects their content. Now some of you might get one doubt. Okay, interesting one. So you'll ask me that, sir, you told us few minutes back that all the videos stored in the S3. Now here you are checking this block all public access. So how the customers, Netflix users, watch the videos, the movies? Because you have checked block all public access. That means no one can access the S3. Like how you will serve the videos, how Netflix serve the videos from S3 to the users. Absolutely correct. But I've told you, just see here, users only access the videos through our streaming service, which generates pre-signed URL. You are absolutely correct. I can uncheck it. But in that case, anyone can download without authorization. no security, blunder, Netflix gone. Okay, that's why I wrote this one line. Just focus on that. Users can only access the videos through our streaming service. In the architecture I've explained you that content service, video service and streaming service is Spring Boot side. Okay, we will configure it, we'll code it. So a streaming microservice generates a pre-signed URL that is private to the particular user and has the expiry so that no one can use it, can't share permanently. So the flow is, let me just show you the flow, pay attention here. So suppose this is our Netflix video player, okay, Netflix screen, fine, and here are the movies. Okay, this is my user, and once user clicks on the play, our backend is streaming service. Okay, so backend and all the microservices, among them is streaming service generates pre-signed URL. Okay, we'll code it, I'll show you. Okay, we'll code it. It looks like the URL looks like HTTPS, okay, and let's say Netflix is streaming videos.s3.amazonaws.com and encoded, okay, movie, then movie 123, then master.m3u8 and so on. Okay, then users video player uses this URL to play the video. Okay, plays, and also this URL got expired after few minutes. See, perfect security, best security. Understood? Okay, so yeah, you can take the screenshot or fine. So this is what, and just scroll down, okay, till bottom and just create bucket. Okay, fine. So can you see our S3 bucket is created, Netflix streaming videos, and this is what our suffix. Now search IAM. Okay, just click here and okay, yeah, just IAM users. Okay, create users, fine, give the name, any name you can just give, YD prod and Netflix. Okay, any name you can just give. Okay, click on the next, and now here you need to select this attach policies directly. Okay, and you need to search here S3 full, yeah, Amazon S3 full access, just check this. Okay, and next, yeah, create user. Okay, now this is what, click on this username, and here can you see create access key, just click on this. Okay, and here you need to just select application running outside AWS. Yeah, select this application running outside AWS and click on the next. Okay, so this is what description tag value. Okay, if you want you can just give it, else just create the access key. Okay, yeah, so you will get the access key and secret access key because we need these two in our project, Netflix project. Okay, fine. So you can just download .csv file and keep it in a secure folder or a secure place. Okay, fine. So that's it, done. Our infrastructure is up and ready, all running. Fine. So now let's move to our Spring Boot part. First let me set up all my project and let's go code our Netflix project. Okay, let's go. Okay, so now let's set up our project. Let me go to my browser and Spring Initializer. Fine. project Maven, language Java, Spring Boot version, and here com dot netflix dot, so at first encoding service, okay, not here, yeah, okay, encoding service, and the dependencies we need web Kafka S3, Kafka Spring for Apache Kafka S3 will add using external resources, okay, directly will copy paste in our pom.xml, okay, and the rest is Lombok. I'll show you, okay, I'll show you what dependencies, okay, and actuator, fine, yeah. So just type mvn repository, okay, just see here mvnrepository.com, and here in the search bar just type AWS SDK, okay, yeah. So the second one, not the first one, okay, like just check here, it should be not the Apache client one, okay, we need this S3 dependency, okay, so click on this, okay, just scroll down, current version, and yeah, this is the dependency, we'll copy it, okay, software.amazon.aws SDK and artifact ID S3, okay, we'll copy this directly, paste once we'll import our all these projects and into our pom.xml, okay, yeah. For now everything looks good, packaging, configuration, YAML version. Let me generate my project, okay, generate, save, yeah. The next is streaming service, okay, fine, just remove the hyphen from the package name, yeah, streaming service, okay. So in that one we need dependency S3, okay, for that we'll just copy and paste, and another is Redis, okay, so Spring Data Redis, fine. So let me show you Spring Boot starter data Redis, okay, let me just generate this too, save it, okay, saved. The next is our video service, okay, remove the hyphen from the package name, and just okay, remove the Redis dependency, okay, Spring Web, Kafka, Lombok, Actuator, and S3, okay, fine. Let me generate this too, okay, save, and one more, the last one is the content service, okay, content service, yeah. So just remove the Apache Kafka dependency and data JPA, then MySQL driver, okay, then what, validation, okay, and that's it, yeah. Okay, yeah, fine, that's it. If required we'll add it later on, okay, once we'll code, fine. So let me generate this to content service and save it, okay. So now let me go to my file explorer, okay, extract and import the project, okay. So let me just extract these all services, okay, then extract all, okay, okay. So now let me import them to my IntelliJ code editor, okay. So you can see I imported all the services, okay, to my Netflix folder, fine. Now we need to add the S3 AWS S3 dependency, okay. So let me go to my browser, and here let me just copy this and to our encoding service pom.xml, okay. So yeah, let me do after that, I don't need the comments, okay, fine, yeah, okay, that's it, yeah, done. Similarly the streaming, so in the streaming, okay, paste it here, okay, and our video service, okay. So same thing. Yeah, done. Fine. Okay, so now let's start one by one coding our all the services. So let's start with our content service. Yeah, so now one important instruction, I want all of you to code with me. Okay, fine, try to code with me. Okay, fine. So let's start our coding part. Okay, so if you remember, in the HLD architecture we have discussed that content service is our movie catalog. Yeah, think of it as the database of all Netflix content. Yeah, it stores movie title, description, genre, thumbnail URL, okay, cast and all other things. Yeah, okay, so let me quickly start. Okay, new Java class model dot movie. Okay, fine. And now private string id. Okay, and the generation type as UUID. Okay, so generated value strategy and UUID, right? Okay, at id. Fine. Next, private string title, private string description. Okay, and then private genre. Okay, genre. So let me create the enum for that because we have bunch of string values. Okay, so okay, yeah. Next is so private and string director. Okay, then private string cast. Okay, then private int release year. Okay, fine. Then private so movie rating. Okay, we need to add all the fields. Then private string thumbnail URL. Okay, then private int and movie duration. Okay, so duration in minutes. Okay, fine. Then also need to provide S3 properties. So S3 key for the video file. Okay, we need to keep track of that. So private string and video key. Okay, then the next is for the HLS also, HLS master playlist URL for streaming. Okay, so private string HLS URL. Okay, fine. The next is the status, like video is uploaded pending failed. For that we have bunch of the string values, so we'll create the enum for that too, video status and video status. Fine, let me just copy it and enum. Okay, the next is last two properties, private and local date time, created at and private local date time updated at. Okay, fine. So now let me just add annotations. Okay, at table name movies. Okay, at data, then at no args and at all args. Fine. Okay, then also let me add few annotations here too. At column nullable false, let me remove the unique. Then here at column, okay, it can be null, the description can be null, and let me just add the length as 1000. Okay, fine. For the genre, let me just add okay enum type dot string also, yeah, here too at enum type dot string. Okay, also let me add comments like status of video processing. Okay, fine. So this is done, our movie entity. The next is, let me just finish these two, genre and video status. So genre means type. Okay, what type of film? Okay, so can be action, then can be comedy, then can be drama, okay, then horror, okay, then thriller, fine, and romance, okay, then can be documentary, okay, can be documentary, or can be animation, okay, and yeah, can be science fiction. So science fiction, okay, yeah. Also video status. First let me add the comments. See, comments are really important because it tells us what's going on and the flow. Please do not skip. So it tracks the video processing life cycle. Okay, let me just show you the flow. Okay, so first pending, okay, then video uploaded, movie uploaded, okay, then encoding, and then ready. Yeah, so this is what the flow. Also, okay, else failed. Yeah, so these are only the status and the complete flow: first pending state, uploaded, encoding, and ready or failed. Okay, so pending, then uploaded, then encoding, okay, then 1 second, yeah, so encoding is a process, and after that encoded, okay, encoded, and then ready. Yeah, so I forget that, encoded, and then ready, failed. Okay, also so like movie added but no uploaded yet. Okay, then here like raw video uploaded to S3. Okay, then here FF, okay, is encoding the video, okay, FFmpeg encoding the video. Then what? Okay, encoded means what? Encoding complete, okay, and ready. What ready means? Yeah, so HLS, HTTP live streaming playlist ready and can be streamed, okay, or oops, encoding failed. Okay, yeah, so this is what each status does. Okay, so this is what our model package done. The next is, let's start our DTO and controller. Okay, so first let me just controller dot content controller. Okay, also we need two DTOs, right? So DTO dot first is movie request, and in response what we get, so movie response. Okay, fine. So first let's do these two, the fields when user try to add movie, okay, into the Netflix. So private string title, and then private string description, then private genre. Okay, then private, so let me just put them side by side. Okay, you just come here, fine, and where is that movie request? Okay, so genre, and then director. Okay, then cast, so movie, cast, and then release year. Okay, and then rating, thumbnail, and duration in minutes. Okay, fine. So this is what our movie request DTO at data and at no args, at all args. Okay, let me just add some validation. So at not blank. Okay, and message will just title is required. Okay, fine. Also for the genre, not null, not null. Okay, and messages genre is required. Okay, yeah, that's it. Now same thing for the movie response. Okay, in response what the fields will get, let me just add all the fields. Okay, till here, and then we'll see later on. So yeah, ID. Okay, let me first, yeah, so ID, description, okay, genre, then director, cast, release year, rating, thumbnail, duration in minutes. Okay, and then yeah, for the video key, okay, let me just remove this. Okay, HLS URL, video status. Okay, also one more field, that is, oh, 1 second, we forget something. We forget to add here creation timestamp and at update timestamp. Okay, fine. So this is what our movie response, and we'll get the response, not that, at data, at no args, and at all args. Okay, fine, let me remove all these also. Yeah, that's it. Okay, so this is what our movie response. Fine. So now let's add our endpoints. Okay, it's APIs. Fine. Okay, REST controller and request mapping. Okay, API v1 and movies. Okay, and then SLF 4J. Also let me just create the service dot content service. Okay, fine, and private final content service. For that let me add required args constructor. Okay, yeah, so now let's start adding the endpoints. First, if user add new movie. Okay, so add movie to catalog. Yeah, okay, for that public response entity. Okay, and in return movie response, response. Okay, and add movie. Okay, at valid at request body. Okay, and we'll pass the movie request. Fine. Okay, so 1 second. Okay, what we need to return response entity dot status. Okay, and http status dot created. Okay, then body and content service content service dot add movie. Okay, and we'll pass the request, movie request. Okay, and we'll create this method, we'll implement this method in our service class. Okay, so it is a post mapping. Fine. The next is get all movies. Okay, so let's quickly create all the endpoints, response entity and list. Okay, list of movie response and get all movies. Okay, so return response entity dot okay and content service dot get all movies. Okay, fine. Get mapping. Yeah, now we need to get the movies by genre and by ID. Okay, so public, okay, and response entity, so list of movie response and get movies by genre. Okay, 1 second. Fine. Okay, so add path variable and we'll pass the genre here. Yes. Okay, and return response entity dot okay content service dot get movies by genre and we'll pass the genre. Okay, what we are getting, and get mapping and what genre here, path variable, right? So genre. Okay, also let me just comment get movies by genre. Okay, like by thriller, horror, drama, action, comedy, whatever. Okay, similarly just let me copy and paste and get movie by ID. Okay, so here we'll just pass the string and movie ID. Okay, and here movie ID and here by ID. Okay, and here let me just movie ID. Okay, and get movie by ID. Okay, also not list. Okay, because one ID, one movie. Yeah, okay, fine. And the last one is search movies. How to search? Okay, so public response entity, okay, and list of movie response search movies. Okay, so request param and string by title. Yes. Okay, so return response entity and dot okay content service dot search movies. Yes, and title, right? So this to get mapping and search. Yeah, so this is what all our endpoints. Let us quickly implement all these methods in the content service. Fine, and then we'll just quickly wrap it up. Okay, not much in this content service. The actual thing starts from video streaming and encoding service. Okay, fine. So content service at service at slf4j. Also let me create the repo. So repository dot content repository. Okay, fine. Extends jpa repo. Okay, so movie and string. Yes, yeah. Okay, fine. Movie and string. Okay. Oops, yeah. So here private final content repository. Okay, and required args constructor. Okay, let's start implementing the methods. Yes, okay. Add movie and returning the movie response. Fine. So public, first let me add some comments. Okay, comments are really important. Add a new movie to the catalog. Okay, and then video is not uploaded yet at this stage. Okay, it's not been uploaded. Okay, fine, to the S3. So public returning the movie response, add movie, and we are getting the movie request. Okay, fine. So let me add some loggings, log.info, and adding new movie. Okay, then what? Request.get title. Okay, fine. So now movie equals new movie. Okay, so I'm creating an object using the new operator. You can just go with the another approach, that is using the builder. Okay, so just add the builder annotation here. Okay, and here instead of this, movie dot builder, and then all the fields. Okay, like title, so request dot get title. Okay, but fine, let me just keep the simple one. You can just go with any of the approach. Okay, fine. So new movie, and then movie dot set title, so request dot get title. Okay, so let me just do fast forward with all the fields. Okay, so set title, description, genre, director, cast, release year, rating, thumbnail URL, and duration minutes. Also one more remaining, that is movie dot set video status. Okay, set video status. So video status, okay, can you see the flow? Currently should be pending. Okay, so that is what we need to set. Video status pending. Fine. Okay, then movie saved movie equals movie, content repository dot save. Let me just rename it. Okay, let's rename it as a movie repository. Fine. Okay, so then movie repo. Okay, and yeah, and here too movie repo. Yeah, fine. And let me just add some loggings, log.info, and movie. So movie added with ID as saved movie dot get ID. Okay, now we are returning the movie response. Okay, so we need to convert this object into movie response. So return map to response, and we'll pass the saved movie. Okay, and this method is nothing but it is just converting the movie object to movie response by setting the values. Okay, so private and returning the movie response, map to response. I'm getting the movie response equals new movie response. Fine. Okay, and then response dot set id. Okay, movie dot get id. So let me just do fast forward. Okay, fine. Set all the fields and then return the response. Yeah, so this is done. Movie added. Okay, next is what? Get all movies. Okay, simple. Just do it at your own. Okay, code along with me. Fine, this is the instruction. Okay, yeah, so it's nothing but get all movies in the catalog. Okay, fine. Okay, so public list of movie response and get all movies. Yes, yeah, and for that return movie repo dot find all. Okay, dot stream, then dot map, so this, and map to response. Okay, and dot collect collectors dot to list. Okay, done. Yeah, so now the next is get what? Get movie by id. Okay, fine. So public, what is that? Get movie by id. Okay, public returning the movie response and get movie by id. So I'm getting the movie id. Okay, and first let me just get the movie for that id. Okay, so movie repository dot find by id and movie id, or else throw. Okay, or else throw new runtime exception and movie not found. Okay, and the movie id. Okay, movie id. Okay, else return if found, then return map to response and we'll pass the movie. Okay, fine. Then get movie by genre, get movies by genre. Okay, so here get movies by genre. Okay, so public and list of movie response. Okay, and get movies by genre and genre, right? So return movie repository dot find by genre. Okay, so we need to create this query method. Okay, genre. Okay, let's create this method in the movie repository. So list of movie and find by genre. Okay, genre, yes. Okay, created. Now where is that? Yeah, dot stream dot map, okay, this, and map to response, and then same thing, collectors dot to list. Okay, fine. Okay, our last endpoint is search movies. Find search movies by title and returning list. Okay, so let's implement this public, okay, list and movie response search movies, and I'm getting the title. Okay, fine. Now return movie repository. Okay, and we need to create one more query method, okay, to search movies by title. Okay, so let's do it in the movie repository, returning the list of movie, and no, not that. So just look at here, find by title, right? Now we should also ignore the case. Yeah, for that, containing ignore case. Yes, containing ignore case. Okay, fine. So let me just go to my content service and dot find by, and I'm passing the title, then same thing, stream, okay, then map dot map, okay, and this map to response, fine, and then dot collect collectors, okay, collectors dot to list. Okay, yeah. So also let me just write comments as search movies by title. Now wait, we need to implement two more methods. Now you might be thinking that we have already implemented all the methods like add movie, get all movies, get movies by ID, get movies by genre, search movie. What else remaining? Okay, just look at here, okay, important thing. In the movie entity, we have added two more fields. If you remember, video key, that is our S3 key, and our HLS URL, HTTP live streaming URL. And we need to update these two fields. Yes or no? For that, we need to create two more methods. Okay, so let's do it quickly in the content service. Okay, yeah, so public void update video key, okay, and I'm getting what, a string movie ID, okay, and a string video key. Okay, so first let me add some loggings. So log.info and updating video key for movie, so movie ID. Okay, then first let me get the movie. Okay, first let me get the movie. So movie repository dot find by ID. Okay, and let me pass the movie ID. Okay, if not found, then or else throw new runtime exception, okay, that movie not found, okay, and movie ID, yes, okay. Okay, so if found, then let's update it. So movie dot set video key, and I'm getting the video key. Okay, also we need to update the status, movie dot set where is that video status to. So at first the default is pending, the next is uploaded. Okay, why uploaded? Tell me why uploaded. Tell me in the comment box that why uploaded. Okay, the next is let me save the movie in the database. Okay, fine. Why uploaded is because just rewind the architecture and flow what we have discussed. The content service job is to add a movie. Next is our video service. Look at here. Video service job is to upload that movie to S3. Okay, that movie to S3. Okay, we'll get the S3 key and we'll call this method. Yes or no? So once movie added, next step is video service upload that movie to S3. We'll get the S3 key, will update the S3 key or video key to the movie, and then we'll update the status as uploaded. The movie is uploaded to S3. Yes or no? Next method, which is our update our HLS URL. Now public void update HLS URL. Okay, so first is movie ID, okay, and the second is string HLS URL. Okay, fine. Okay, string done. First let me add some loggings, log.info, and updating HLS URL for movie, okay, and movie ID. Okay, then let me first get the movie, so let me just copy paste. Okay, if not, movie not found. If found, then we'll update the HLS URL back. Okay, so set HLS URL, and now the status, set video status to ready. Okay, ready, and then save the movie in the database. Okay, fine. Also just look at here the loggings. Let me update as movie is now ready for streaming. Okay, and movie ID. Okay, yes, movie is now ready for streaming. Okay, why? Because so the second step is video service. Okay, uploaded. The third step is encoding. Once encoded, we'll get the HLS URL. Okay, we'll again call this method to update the HLS URL in the movie object, and now set the video status as ready. Okay, so ready, pending, uploaded, encoding start, encoding done, ready. Okay, so this is what our two methods we created. Two methods to update both of our fields. Okay, HLS URL and video key. Fine, so let's quickly add the properties. Okay, so spring dot application dot name content service. Okay, and then spring dot data source. Okay, then URL, so JDBC. Okay, then MySQL localhost, okay, 3306, and the database name, right? So let me just open my MySQL command line. Okay, and create the database, and what, content db. Yes, okay, created content db, fine. Yeah, then what, username, okay, password, fine, and then driver class name. Okay, so com dot mysql dot cj dot jdbc, dot driver. Okay, so you can just enter your own username password. Fine. Okay, and then JPA, then hibernate, okay, DDL auto update, show SQL true, yes, properties, okay, hibernate and dialect. So go to the search here and type MySQL dialect, okay, and copy this path org.hibernate.dialect, okay, dot MySQL, yes, what is that class name? MySQL dialect, okay, MySQL dialect, yes, yeah, okay, fine. Now server dot port 8081, okay, and actuator, so management, okay, then endpoints, web exposure, include health info. Yeah, okay, so this is what we have completed our content service. Okay, quickly let's start our video service. Okay, so at first let me complete the skeleton. Okay, so controller dot video controller, okay, and service dot video service, fine, and event, right, so event dot video uploaded event, okay, we need to publish the event, okay, and then config, okay, the important classes config dot, so first Kafka config, okay, Kafka config, and then S3 config, right, S3 config, okay, yeah, so let's start with our video controller. Okay, so at REST controller, at request mapping, okay, so here API v1 and videos, right, and SLF4j, okay, fine, private final video service, okay, at required args constructor, yes. Now just pay attention here, so upload video file for a movie, yes, yeah, okay, then yeah, accepts multi-part file upload, okay, and also the endpoint is post mapping and API, okay, then v1, okay, videos and upload, and here movie ID, okay, yeah, now it's clear. Okay, so let's public response entity, okay, and string, fine, and the method name is upload video, okay, and here so we'll pass two things. First is path variable string movie ID, okay, and the second thing is request param, okay, request param, and file multi-part file, okay,
fine, good. Yes, okay, yeah. So now okay, log.info video upload request for movie file size MB. Okay, so what, movie ID, okay, and file dot get size, yes, and we need to divide it by 1024 cross 1024. Okay, why dividing 1024 cross 1024? Because to convert the file size from bytes into megabytes. Okay, the next is we need to add a check if file dot is empty. Okay, then return response entity dot bad request dot body. Okay, and we'll just write file is empty. Okay, if not, then we'll get the video key, okay, from the video service. Yeah, the same key, this one, main java model movie, and here video key, S3 key. Okay, so video service dot upload video, okay, and it returns the video key, will pass the movie ID and file here. Okay, and then we'll return response entity dot, okay, and video uploaded successfully, okay, key, so video key, okay, and encoding started automatically via Kafka. Good, it's good. Okay, fine. And yeah, post mapping, okay, upload and movie ID, also throws IO exception. Perfect. Now let's implement this method, upload video. Okay, let's go. So video service at service and at slf 4j. Okay, so now we need few things. First, private final S3 client. Okay, for that let me add required args constructor annotation. Okay, then private final and Kafka template. Okay, Kafka template string and video uploaded event. Okay, Kafka template, yeah, and then we need our bucket name. Okay, S3 bucket name, which we have created in the S3 console. Okay, so we'll get it from our properties file value. Okay, yeah, okay, then so AWS dot S3 dot bucket name, fine, and we'll configure it in our application.yml file at the end. Okay, yeah, and one more thing we need, private static final string video uploaded topic. okay, Kafka topic. So let's say video dot uploaded. Yes, okay, yeah. So here we starts our uploading process. Okay, fine, pay attention here. Upload video to AWS S3 and publish video uploaded event to Kafka. Okay, and the flow which I have shown you here. Okay, so number one is first receive multi-part video file. Okay, so yeah, that is what this file. Okay, done. The next is number two, generate unique S3 key. Okay, fine. Number three, that is upload to S3. Okay, fine. Okay, number four, that is publish video uploaded event to Kafka. And number five, encoding. Number five, encoding service picks up and start processing. Okay, yeah, so this is just remember these 5 points and it's done. Yeah, video service job is done. Uploaded to S3, then encoding service picks up and start the processing. Okay, let's start. So public and a string upload video, right? So upload video, I'm getting movie ID and file. Upload video and I'm getting a string movie ID. Okay, and multi-part file. Okay, let me add some loggings info. Okay, and starting video upload for movie. Okay, and file, so movie ID and file dot get original file name. Okay, yeah, now let's generate unique S3 key for video, or I can say for raw video. Yes, okay, and format. So format is let's say raw movie ID. Okay, then UUID. Okay, underscore file name. Yes, okay, so this should be our format. Okay, so a string video key equals raw, right? So raw. Okay, and then movie ID, so movie ID. Okay, plus, and then UUID dot random UUID. Okay, then plus underscore, right? So underscore, then plus file dot get original file name. So this is what, you know, first I've shown you the format, and this is what the format. In this format we have generated the video key. Okay, raw movie ID, then random ID, and then underscore file name. Now we need to build the request. Pay attention here. Now we need to build the request. What request? Request to send the video file to S3. Okay, so we need to build the request and then we'll send our file to S3. How to do it? Let me start coding that part. Okay, yeah, let's start. 3 2 1 go. Okay, put object okay, request. Okay, so it is under the package software Amazon AWS SDK services S3 model and put object request. Okay, fine, and put object request equals put object request. Let me use the builder. Fine, and then we need to give the our bucket name. So bucket name is, we'll get it from here. Okay, then I need to just give the path, that is the key, so video key. Then we need to just inform about our content type. Okay, content type, so file dot get content type. Yes or no? Okay, file dot get content type, and then length, so content length. Okay, so again file dot get size and then dot build. Yes, okay, now let's send it to S3. So S3 client, okay, dot put object. Okay, and we'll pass this put object request, so we need to pass this request. Okay, and then request body. Okay, request body, not empty, dot from input stream. Okay, and we'll pass file dot get input stream and the size, file dot get size. Okay, now can anyone tell me why I'm getting this error? Yes, okay, so throws IO exception. Okay, gone. Yeah, so now log dot info. Okay, and our video is uploaded. To S3. Yeah, okay, again I'm just saying our video is uploaded to S3. This is what we have built, the request to send the file to S3. It's done. Okay, good job. Yeah, fine, so video uploaded to S3 successfully. Okay, and key, so video key. Right, now the next job is Kafka, publish event to Kafka, and then encoding service will what, consume this and start FFmpeg processing. Yeah, so next, see, these all services are the steps. Okay, first is content service. Okay, then video service uploaded to S3. Okay, done. And then publish event to Kafka, the encoding service consume this and start this. Okay, later on the streaming service consume the encoded that event and start the streaming. Yes or no? Yes. So uploaded event, right? Okay, so let me just add the fields here. What fields? First comments. Okay, so event published to Kafka when a video is uploaded to S3. Okay, and encoding service consume this to start. Okay, I hope you got it. Also, let me just mention the topic. Okay, video dot uploaded. See how I'm just coding the project. Comments. Yeah, so this is the best way. Fine. So the fields are private, string, movie ID. Okay, then video key, private, string, video key, then bucket name, private, string, bucket name. Okay, and then file name, so private, string, original file name. Okay, and then size, so private, long, file size in bytes. Okay, done. And then add data, add no args, add all args. Okay, so yeah, here was that video uploaded event. Video uploaded event equals new video uploaded event. Okay, in that movie ID. Okay, and then video key, and then bucket name. Okay, then file dot what, get original file name, and then size, so file dot get size. Okay, fine, that's it. Okay, and now let's send it. So Kafka template dot send, and the topic, right? So video uploaded topic, movie ID, and event. Okay, event. Then let's add some loggings here too. So video uploaded event published for movie ID. Okay, yes, and we need to return the video key. Okay, that's what we need to return. Yes or no? Yes, in the controller video key. Okay, so this is done. Good, great. Fine. Now three things remaining, that is configuration, S3, Kafka, okay, and properties file. Okay, let's do one by one. Kafka config. Okay, at first add configuration and two beans, right? The first one is public new topic and video uploaded topic. Okay, and the second one is public new topic and video encoded topic. Okay, so uploaded video dot uploaded and video dot encoded. Fine, so the comments are published when video is uploaded to S3. Okay, and for this published when encoding is complete. Okay, so return topic builder, okay, dot name, and the name is what we kept, video dot uploaded partitions. Okay, 3. Fine, then replicas 1. Okay, and dot build. Yeah, so now return and topic builder dot name, and for this video dot encoded. Okay, and partitions 3, replicas 1, build. Yes, also the important annotation bean and at bean. Okay, fine. Now I want you to comment me down. Okay, so one more comment, let me just write it. Encoding service consume this. Okay, for here I want you all to comment me down what comes here. Okay, simple, right? Video uploaded topic. Okay, once uploaded, encoding service consume this. Okay, once encoded, okay, once encoding is finished, complete, then what? So comment me down. Okay, let's move to our S3 configuration. Okay, so configuration, fine. Now I need few things here. Private and string access key. Okay, we'll handle it from our properties. So value, okay, and AWS dot access key. Okay, similarly private string secret key. I hope you have already downloaded the file and kept the access key secret key file in a secure place. Okay, value, so AWS dot secret key. Okay, and private string region, right? So at value and AWS dot region. Okay, fine. So now public S3 client. Okay, not this, S3 client. Okay, S3 client, and return S3 client dot builder. Okay, dot region. So we'll pass region dot off and the region. Okay, this one, fine. Next is credential provider. So a static credential provider. Okay, dot create. Okay, and AWS basic credentials dot create, and we'll pass the access key and secret key. Okay, good, and then build. Yeah, at bean, fine. Now S3 pre-signer. If you remember, I've explained you while creating the bucket. Okay, important one. So S3 pre-signer. Okay, yeah, return. Okay, S3 pre-signer dot builder. Okay, then region. So region dot off and pass the region. Fine, then same thing. So let me just copy and paste. Okay, dot build. Yes or no? Okay, got it, fine. And at bean. Yeah, so it's done. Now only one thing remaining, that is application properties file. Let's do it quickly. Okay, so Spring, then application name, so video service. Okay, then Spring dot Kafka. Okay, and bootstrap servers localhost 9092. Okay, then producer. Okay, so key serializer. Okay, and org dot apache.kafka common dot serialization dot string serializer. Okay, 1 second. Yeah, and key, so value serializer. Okay, so org dot spring framework dot kafka dot support dot serializer dot json serializer. Okay, then multipart file, so spring dot servlet dot multipart. Okay, and max file size will mention. Okay, so 2 GB, fine, and max request size 2 GB. Yes, okay, fine. Now server dot port, so running on 8082. Okay, now let's AWS configuration. Okay, fine. So AWS and access key, right? Access key. Okay, and then secret key. Okay, then region. Okay, region, fine. Then what? Oh, 1 second. So okay, AWS, see, access key. Okay, and your access key. Okay, for the production, fine. Okay, similarly AWS, okay, secret key and your secret key. Okay, you can just write it here for now for the development purpose. Okay, your access key, your secret key. Okay, and then here AWS region. Okay, and if we'll check the URL, okay, the URL, so it's like, you know, it's like let's say AP South 1. Okay, it's like this, fine. Now S3 and bucket name. Okay, so AWS bucket name. Okay, and what the bucket name I've kept, I don't know, I'll write it later on. Okay, fine. So for now ABCD bucket, fine. I need to check it. Okay, at the time of testing we'll just, you know, enter everything else, fine. And then actuator, so management endpoints, then web, then exposure, include health info. Okay, got it? Yeah. So this is what our application properties file for video service. Okay, I guess everything is done. Video controller, video uploaded event, and the service where we have implemented our upload video. Okay, and uploaded our video to AWS S3 and publish video uploaded event to Kafka, and these are the steps with proper comments. Okay, and properties file. Yeah, so now let's move to our next service, that is super important service, that is encoding service. Because here in this encoding service, we need to do multiple things, a lot of things. Okay, so the main encoding pipeline is like, first download the raw video file from S3. Okay, we need to first download it from S3, and then we need to encode to multiple qualities like 1080 pixel, 720 pixels. Okay, and then we need to generate what, HLS playlist. Okay, if you remember, .m3u8 for each quality. Okay, fine. And then we need to create the master playlist. Okay, and then we need to upload all encoded files back to S3. Okay, chunks. Okay, chunks. And then we need to publish video encoded event to Kafka. Okay, and how we're gonna do it? It's a way long process. Okay, fine. So really excited. The two important service, encoding and streaming. Okay, fine. So without wasting much time, let's start coding our next service, that is encoding. Fine, let's go. Okay, let's build our encoding service. So new Java class service dot encoding service. Okay, remember this thing, encoding service class is the most crucial and most important. Fine. So the next is consumer. Okay, video event consumer. Fine. So yeah, definitely, as we discussed few minutes before, that encoding service consume the video uploaded event. Okay, in our video service. So here video service, yeah, video uploaded event, encoding service will consume this and start processing. Okay, fine. And the next thing is, okay, the next thing is what, event. So event dot two events. Fine, the first is video encoded event. Okay, and the second one is obviously video uploaded event. Okay, and the last, that is config dot s3 config. Okay, let's start building encoding service. Okay, please pay attention, don't shift your focus anywhere. Okay, keep your phone shut down or on silent. Fine, because nothing is important than our encoding service at SLF4J. Fine. And now I need few things, private final S3 client. Okay, so yeah, S3 client. Okay, add required args constructor. Okay, now I need private final Kafka template. Okay, Kafka template and string, and then video encoded event and Kafka template. Okay, yeah. Now also I need my bucket name, so I'll get it from properties bucket name. Okay, and add value. So what, AWS dot s3 dot bucket name. Okay, so I'll get it from there. And yeah, so also I need FFmpeg path. Okay, ff path. Okay, so add value, and the same I'll get it from where, properties path. Okay, yeah. Now topic, right? So private static final string a string and video encoded and topic. Yes, okay, so video dot encoded, right? Yeah, now comes our qualities. Okay, so just pay attention here. So let's consider 4 qualities, okay, as we discussed in our architecture. So also let me just write the command video qualities to encode, okay, and the format is first resolution, then bitrate and then height. Okay, fine. So private static final list of array. Okay, so okay, and video qualities, yeah, equals arrays dot as list. Okay, let me import it, and the first is new int, fine, and so resolution 1920, fine, bitrate 5000 and it is 1080. okay, also let me write the comments as 1080 pixel. Okay, that means 5000 k bitrate. Okay, it is kbps, fine. See, don't worry, let me just finish the video qualities and I'm gonna explain it everything, like what is this 5000 kbps. Okay, fine, what is this bitrate and everything. Okay, yeah. So next is new int and 1280. okay, then and for 720 pixel. Okay, yeah. Next is 480 pixels. Okay, so 854 and 1000. Okay, and okay, let me just keep it as 1200. Yeah, fine, and 480. okay, and then finally 640. okay, and for this okay, 700. okay, 800 is fine, and 360. okay, also just once again I'll explain it, don't worry, let me just write the comments. okay, 720 pixels. okay, that means 2.8 million bitrate. okay, and 480 pixel, that means what, 1.2 million bitrate, and the last one is 360 pixel. okay, okay, fine, 360 pixel and it is 0.8, so 800k bitrate. okay, now what is this 5000 kbps bitrate, okay, for each qualities, and what is bitrate means, can you explain? Yeah, so see, bitrate represents how much data is processed per second. yes, so higher bitrate, that means better visual quality. okay, and lower bitrate, that means some blur image quality. okay, and generally good for slow connection. okay, so if you set the quality to 1080 pixels. That means higher bitrate. The quality improves 5 million kbps. Okay, and lower bitrate, that means some blur image quality. Okay, somewhat not clear, but good for slow connection. Okay, now let me explain you what are these numbers. Okay, fine. So you just go up. Okay, so 1080 pixel and 5000k bitrate. Fine. So this K stands for kbps. Okay, now listen to me, pay attention here. If internet is faster, then our video player, our video player can easily downloads the 5 million bits per second. This 5 million, 5000k, or I can say 5 million bits per second. Why? To download the 5 million bits per second to draw the picture and deliver. Understood? So once if your internet is faster, okay, so in case of 1080 pixels high resolution, that means video player can easily download the 5 million bits per second to draw the picture. What is a video? It's a picture only. But if you if you explicitly set the quality to 1080 pixel and your internet is slow down, okay, in that case what happens? It can't able to download the 5 million bits per second. So what it cause? It cause buffering. Yeah, buffering. So that's why we have other qualities, and it automatically switched to 720 or 480 to or 360, 1.2 million bits per second, okay, or 360 just 0.8, 800k, okay, 0.8 million bits per second, and video runs smoothly. Yes or no? Okay, yeah. So this is what our bitrate and creating this. Okay, fine, let's proceed forward. Now main encoding pipeline. Okay, public void encode video, right? And video uploaded event. Okay, fine. So main encoding pipeline. Okay, steps. Yeah, number one, what are the steps? So our video service, okay, what it does is video service uploaded the movie, okay, video to S3. Now we need to encode it. So what is the step number one? First we need to download raw video, that video which is uploaded to S3. We need to download it from S3. Okay, yes. So step number one, that is download raw video from S3. Okay, number two is we need to encode to multiple qualities using FFmpeg. Okay, processing. Next is step number 3, generate HLS playlist. Okay, as we discussed in our HLS architecture that we covered, what it means, dot m3u8. okay, for each quality, yeah. And the fourth step is we need to create master playlist. Okay, fine, master playlist. Okay, and the fifth step is now we need to upload all encoded files back to S3. Okay, so what's the process is, so video service uploaded to S3. Now we need to encode it. Okay, we need to stream, so first we need to encode it. Okay, so first we need to download from S3, do all the process, encoding, generate the HLS playlist, okay, master playlist and everything else, and then back to S3. Yeah, I have explained the chunks, okay, for each quality. Okay, and then the last step is Kafka. So we publish video encoded event to Kafka. So these all are the 6 steps, 6 crucial steps we are going to code. Okay, fine. So let's start log.info. okay, and starting encoding platform for movie. Okay, and event dot get. Okay, so let me just add the fields here in the video uploaded event. Okay, so let me just copy and paste from the video service event. Okay, this one, same thing here, add data, fine, and no args, all args. Also let me add the comments, consumed from Kafka topic and video dot uploaded. Okay, yeah. So back to our encoding service and event dot get movie ID. Okay, the next is our step number 1. So it says download raw video from S3. Okay, so for that we need a directory. Okay, and we need multiple directories. Okay, so one will get the video, the other one encoded videos. Okay, so yeah, let's do it. Okay, fine. So first let me just get the base path. Okay, private string and base path. So add value and let me get it from the properties. So encoding dot base and path. Okay, fine. So now let me also create a unique path for a movie, okay, or a video. So a string for the encoding job. Okay, so we'll write job path equals the base path, okay, plus and slash, okay, event dot get movie ID. Okay, for each movie. Fine. Okay, so it's like suppose the base path is temp slash encoding. Okay, fine. Inside it there is another
unique path for a movie, job path. So base path slash, so that means inside it for each movie ID. Okay, so let's say movie 1. Okay, so it's another directory. Fine. And in that we will download our video. Fine. So it's like the job path plus slash whatever video1.mp4. okay, so temp slash encoding slash movie1, this is the path, and our the actual file. Okay, so this is one directory. The second directory is once will encode our video. So we'll just create another directory like this path slash encoded. In that directory will kept our encoded videos. Yes or no? Okay, fine. So let's proceed, and now let me open my try catch. Okay, try catch. Okay, fine. So here we'll create it's like temp directories. Okay, temp directories. Fine. Definitely we need, because we'll download the videos from S3, so we need. Okay, and now you might be thinking that why you need a unique path for a movie. So because if suppose there are simultaneously 4 movies. Okay, so video service uploaded 4 movie, M1, M2, M3, M4. Okay, so our encoding service consume and downloads the 4 movie. So for each movie we need a path so that it can't create a mess. That's why. So it's like temp encoding and movie 1, M1, M2, M3 and M4. So these are the 4 directories. Inside it their particular video files, and their encoded files too. Yeah, so let's keep them separate, clean. Okay, that's why. Fine. So let's create it. Files dot create directories. Okay, and paths. Fine. Dot get. So what is this? Job path. Okay, and files dot create directories, paths dot get. Okay, and the job path plus encoded. Okay, for the encoded files. Now step number 1. What's that? Download raw video from S3. Okay, download raw video from S3. Okay, so a string, and we'll set the local video path. Okay, so it is our the job path plus, let's say, raw video.mp4. okay, fine, and then download from S3. okay, so we'll create this method. Fine, and we'll pass event dot get video key. Okay, and this local video path. Okay, so we'll download here, and log dot info, and in that raw video downloaded to what? Local video path. Yes. Okay, now our step number 2 and 3. Yeah, so encode to multiple qualities. Okay, and generate HLS playlist. Fine, so step 2 and 3, encode to multiple
qualities plus generate HLS. Okay, fine. So for that, let's initialize a for each loop. Okay, and int qualities. Okay, video qualities. Okay, and so the first one is width. Okay, yeah, like resolution. The second one is bitrate, and third one is height. Okay, so we can just width equals qualities and at 0th index. Similarly, int bitrate equal quality and 1. Okay, qualities. Okay, and height equals qualities and 2. Okay, fine. Now we'll define our quality directory. Okay, so as we discussed, for each quality, okay, videos for each quality, so the job path, okay, plus encoded, okay, the encoded, and plus height, okay, so the pixels, plus added a p. Okay, so 1080 pixels p. Fine, and we'll create the directory. So this is the path. Okay, this is the path. The directory will create by create directory method and paths dot. Okay, done. Fine, and then we'll encode to HLS. Okay, we'll create this method too, and we'll pass local video path. Fine, and this quality directory. Okay, and all three things: width, height, and bitrate. Okay, fine, we'll create this method, this too. Fine. Okay, now just add some loggings, log.info and encoded. Okay, here encoded pixel successfully, yes, and height. Okay, so encoded 1080 pixels, encoded 720, 480, 360, whatever. Fine. Now step number 4 was that generate master playlist. Okay, fine. For that also we need to create the path. So master playlist path equals job path plus encoded. Okay, and was that master dot m3u8. Okay, fine, and generate master playlist, and we'll pass our path. Okay, so we'll create this method too. Okay, we'll implement this too, log.info and a small message master playlist generated. Okay, fine. Step number 5, that is upload all resources files to back to S3. Okay, let me just create encoded prefix. Okay, fine, so encoded. Okay, and event dot get movie ID. Yeah, fine, and then upload encoded files to S3. Okay, this method too will create. So we'll pass the job path plus encoded. Okay, and the encoded prefix. Okay, fine, and log.info. So all encoded files uploaded to S3. Yeah, okay. Now step number 6, that is publish video encoded event. Okay, so now we need to publish video encoded event. Okay, first let me just add the fields here. Fine. So private string movie ID, okay, and then private string HLS URL. Let me provide for string and master playlist key, private boolean success, okay, and error message, private string error message. Okay, let me also add comment as master playlist URL for streaming, okay, and here S3 key of master.m3u8. okay, yes, yeah, and this is for if encoding failed, then error message. So okay, if, yeah, now back to our encoding service and let's create both string master playlist, okay, key, so encoded prefix plus master dot m3u8, okay, and string HLS URL equals URL, right, HTTPS, okay, bucket name, right, plus dot s3 dot AMAZON-AWS.com, right, and plus master playlist key. Okay, so https bucket name dot s3 dot AMAZON-AWS.com / master playlist our key, right. Okay, now video encoded event equals new video encoded event and event dot get movie ID, okay, then HLS URL, then master playlist key, okay, then true and null, okay, yes, fine. So I guess I forget, okay, at data, then at no args, all args, okay, fine. Kafka template dot send and video encoded topic, also event dot get movie ID and encoded event, yes, and log dot info, so video encoded event published for movie and event dot get movie ID, fine, yeah. Now catch block, okay, so log dot error and encoding, okay, encoding failed for movie, okay, so event dot get movie ID and e dot get message, okay. Now we'll publish the failure event, okay, so let me just copy and paste this video encoded event, and here it's null, here too it's null, and here false, and here e dot get message. Yes, and Kafka template dot send. So video encoded topic event dot get movie ID and okay, one second, failure event. Yes, so failure event, right? And also finally so cleanup temp files, okay, at the end. So cleanup temp files will create this method and will pass the job path. Okay, fine. So now we need to implement these methods: upload encoded files to S3, generate master playlist, encode to HLS and download from S3, and finally clean up temp files. Okay, fine, let's start. So at first, download file from S3 to local path. Okay, so it is private void and download from S3. okay, so over this method. Okay, and what I'm getting, so I'm getting the string, okay, video key and local video path. So S3 key, okay, and string local path. Fine. Okay, so let me just get object request. Okay, not that, get object request, and get object request equals get object request dot builder. Fine, and we'll pass the bucket name as bucket name dot key. So what I'm getting, S3 key and dot build. Yes, and S3 client dot get object. So let me pass this get object request plus paths dot get and the local path which I'm getting. Okay, this one and this one. Fine, downloaded to our local path. Okay, done. Next is our encode, I guess encode to HLS. Okay, yeah, so this one is, you know, quite okay. Let's see, private void encode to HLS, and what I'm getting, okay, automatically populated. Fine, that's good. Local path quality directory. Okay, so let me just, where is that encode to HLS? Okay, local video path and quality. Okay, so let me just, you know, rename those. So it is as input path. Okay, and this is output directory. Okay, width, height. Fine. So at first let me create the playlist path. Playlist path equals output directory, and let's say playlist.m3 uit. Okay, and the chunks, right? So string chunks pattern, or I can say segment. Yeah, segment, you know, .ts. so segment pattern equal output directory plus segment and then %d.ts. Okay, so now let's build our command.
for HLS encoding, okay, for processing. Command line argument FFmpeg command for HLS encoding. Okay, look at here. So list of a string and command equal arrays dot as list, and at first let me copy my FFmpeg path. Okay, yeah, and at first let's start. So -i, okay, command line argument -i and input path. Okay, at first input path will provide, okay, then scale to resolution. So -vf, okay, and scale equals width, okay, and height. Yeah, so see, what are these? What I'm doing here? These are the FFmpeg command line argument. So when you run FFmpeg command in the terminal, in the command prompt, how it's like FFmpeg, it's FFmpeg, okay, and -i, then input file, okay, so like video1.mp4, okay, then we'll provide the scale, okay, so hyphen, this is the command line argument command, okay, -vf, okay, then scale, so scale equals, so we need 1920 resolution, okay, and 1080 pixel, okay, and then these all things. So this is how we'll write the command in our terminal. Yes or no? In the command prompt. Yes, exactly. This is the FFmpeg command we are building with all the command prompt, and each command tells FFmpeg exactly what to do, like which file to process, okay, which resolution to encode to, fine, how long each chunk should be, okay, so we have decided like 10 seconds, maybe 12 seconds, so everything, okay, and this is why we are building the command. Later on we'll just process this command to encode for high level streaming encoding. Yes or no? Yes, okay, so there are around 9 to 10 more commands for each of them: video bitrate, audio bitrate, okay, for the 10 seconds or 12 seconds segments, and then segment naming, okay, chunk naming, output format, okay, output playlist, everything. So for each we have command, and we are building this in Java. Okay, fine. So let me just do fast forward. Okay, and at last we'll provide this playlist path, okay, all these commands and playlist path. Fine, don't worry, let me just add the comment so that it's super easy for you to understand. So this is for the input file, okay, we'll provide, and this is the, okay, resolution, right? So scale to resolution, okay, this is fine, this is the video codec, okay, then okay, bitrate, so video bitrate, okay, this is AAC, okay, so bitrate, this is for the audio codec, audio, and here audio bitrate, audio bitrate, okay. Now the next is, okay, 10, so our chunks, fine, segments, so let's keep 10-second segments, okay, or chunks, fine, and yeah, so let's keep all
segments. Fine. Okay, here pattern. Okay, so this is the naming, segment naming. Fine. And this is our output format, HLS, and this is our playlist path, output playlist. Okay, done. Now the next is, let's process this. So for that, process builder. Okay, process builder equals, okay, we'll just give the command and process builder dot redirect error stream boolean. Okay, so true, and process equals process builder dot start. Fine. Okay, now, okay, so 1 second. And here throws IO exception and interrupted exception. Okay. Fine. Yeah, now int exit code equals process dot wait for, and if exit code not equals 0, then throw new runtime exception. Okay, and it's what, FFmpeg encoding failed with exit code. Okay, and exit code. Yeah, done. Okay, it's done. So this is what our encode to HLS implementation. Let me also add the comment here. Yeah, first encode video to HLS using FFmpeg. Okay, and FFmpeg command creates what? It creates multiple ts segment files. Okay, 10 seconds each, we already discussed. Okay, and .m3 u8 playlist file for this quality. Yes. Okay, yeah, done. Fine. Now the next method, that is our generate master playlist. Okay, fine. So let me generate master playlist, and also for each quality. Yes or no? For each quality we need to generate. Yes. So for 1080 pixel, okay, chunks and their master playlist, for 720 chunks and their, for 360 chunks in there. So just like that. So we need to filter that too. Okay, let's do it. Fine. Private void, and what I'm getting a string. Master playlist. Okay, so master playlist path, master playlist path. Okay, yeah, so first a string builder, and master equals new string builder. Now we need to append few strings. Okay, important for master playlist. So master dot append and ext m3u, okay, and /n. So it tells our video player, it is important one, it tells our video player that this is a extended m3u playlist. Yes, okay. The second one is a version. Okay, version. HLS protocol version. So master dot append and ext. Okay, version, and it's 3. Okay, version 3 /n/n. Okay, widely supported. Okay, version 3. Fine. Now the important thing, we need to add each quality to master playlist. Okay, each quality. Fine. So for all quality we need, right? So 1080, 720, 360, 480. Okay, so let's add it. So qualities. Okay, and the first one is where we have coded that. Yeah, okay, yeah, fine. Then okay, fine. So let me update the values. First let me align those. Okay, and the second one is what? Right, 1280, 720 pixels. Okay, and the third one is 854, 1200, 480. Okay, and the fourth one is what? 800, 640, 800, 640, 360, I guess. Okay, 640, 800, 360. So 640, 800 and 360. Fine, done. And now let me just open the for each loop. Int quality q. Okay, quality is fine, and so int the first is what? Width. So and 0th index, and then bitrate. So q first and height. Okay, q 2, right? Fine, then we'll append it. So master dot append, and we need to provide the bandwidth and resolution and codecs. Okay, and audio video. So for that, what? ext. Okay, x stream. Okay, inf, and bandwidth equals, fine. Okay, dot append and bitrate cross 1000. Fine, dot append, and here so resolution equals, okay, dot append and width, fine, dot append x dot append height, right? And then dot append and cs, okay, equals, then slash, and here so avc1 dot 42 and e01e, okay, and mp4, right? mp4a dot 40.2, fine. And this, right, /n. Okay, it's done. And now master dot append height, okay, dot append, and p playlist dot m3u8, okay, /n, right. Okay, and now we need to write files dot write string and paths dot get, so master playlist path, okay, and master dot toString, just toString. Okay, it's done. Okay, fine. So throws IO exception, done. Okay, yeah, now the next. Also let me just write the comments as generate master HLS playlist that references all quality playlists, okay, and this is the file the video player downloads first, okay, so this is the file video player downloads first. Fine, next method, that is our upload encoded files to S3, okay, this is the last, not second last, and the last one, this cleanup. Okay, so private void upload encoded files to S3, and what's that, job path, okay, encoded prefix, fine. So it's okay, local only, so a string and local directory and a string S3 prefix, okay, and file, let me just import directory equals new file and local directory, fine, and let me just create a new method upload directory to S3, okay, we'll pass this directory here, local directory and S3 prefix, okay, so we need to upload the directory to S3 back, okay, back to S3, all the video files chunks, okay, so encoding done, and then final thing. So let me just create this method private void and upload to S3. So first file, so directory and string, so this is local, or I can say base directory, and string S3 prefix, okay, fine. First let's get the file, okay, so file equals directory, okay, dot list files, okay, and then we'll apply the recursion, okay, so if file dot is directory, then upload directory to S3, and yeah, same thing, okay, else what, else let's relative path, okay, so from file dot get absolute path, okay, then dot substring, so base directory dot length +1, okay, and dot replace / and yeah, okay, we need to replace it with this, fine. Now let's get the S3 key. S3 key equals, so S3 prefix plus relative path. Okay, now content type, so string, we need to set the content type to, okay, so file dot get name, okay, and ends with what, dot m3u8, okay, and then application FFmpeg URL, okay, FFmpeg URL, okay, or if false, then video, so mp2t, okay, ternary operator. Now we need to build the request, so put object request, okay, put request, fine, put request, okay, fine, let's keep it, put object request dot builder and dot bucket name, okay, so bucket name, okay, then key, so S3 key, okay, then content type, okay, content type, let's pass it, and dot build it, right, and then S3 client dot put object, so we'll pass our put object request and our request body dot from file and the file, okay, and also we'll add some loggings, log dot debug, so it's like uploaded, okay, and S3 key, right, okay. Also let me just add the comments here, so what, upload all encoded files from local directory back to S3, okay, so this line says it all. Yeah, that's it. Now only one thing remaining, that is our cleanup, okay, cleanup temp files, so this is too easy, let's complete it quickly. So cleanup temp files after encoding, okay, fine, one second, okay, okay, throws IO exception, and yeah, fine. So now private void cleanup temp files, and what I'm getting job path, okay, so a string job path, okay, let me open the try catch and IO exception, fine, okay, so get the path, and let's say directory path equals paths dot get job path, and if files dot exist, okay, in the directory path, okay, then files dot walk, so directory path, okay, dot sorted, fine, so java dot util, okay, we'll just sort via comparator, okay, so comparator, okay, dot in the reverse order, okay, we'll just provide direct method. Okay, Java gives to us, and path.toFile for each okay file delete. Okay, done cleanup, and we'll just add some loggings, log.info. So temp files cleaned up for job, okay, and job path. Right here in the catch, let's add some warnings. So log.warn and failed to clean up temp files, okay, and e.get message. Yeah, so everything is done. So with this, it completes our entire encoding service. Okay, and at first we have implemented our encode video. Okay, we follows these 6 steps. Okay, download, encode, generate HLS playlist, create master playlist, okay, upload all encoded files back to S3 and publish video, encoded event. Fine. So this is only the important thing, encode video, and that we have implemented multiple methods, okay, like step by step. So download from S3 and then encode to HLS, okay, and then generate master playlist, encode files back to S3, okay, and then clean up. Okay, fine. So I told you, like, one of the most important part of the video, that is encoding service. Now the next thing is the only remaining thing, that is video event consumer, okay, Kafka listener, okay, and then application YML and S3 config, and let's finish it and start our next, that is a streaming service, and then testing. Okay, full testing of our Netflix project. Fine. Okay, let's go. Okay, so now let's code our consumer part. Okay, video event consumer. Fine. Okay, so add service, okay, add slf4j and add required args constructor. Fine. Now private final and encoding service, okay, fine. Let me add the comments. Okay, so what it does is it listens to video dot uploaded, okay, what video service does, okay, video dot uploaded Kafka topic. Fine. And then triggered when video service uploads a raw video to S3. Okay, see, self-explanatory. So the flow, let me also show you the flow. Okay, so first video service, okay, to S3 upload, okay, then Kafka, okay, and the topic is video dot uploaded, right? Okay, then here, then what, then this consumer, okay, so encoding service to FFmpeg, okay, and then back to S3, okay, and then again Kafka, okay, topic is video dot encoded. Okay, just now we have seen in this our encoding service. Okay, so once done, all the videos back to S3 and published to Kafka. Okay, okay, fine. So yeah, let's start. Okay, public void consume video uploaded event, okay, and video uploaded event, and here at Kafka listener. Fine. And topics, so it is video dot uploaded and group ID, so encoding service group. Okay, fine. So let me add some loggings. Okay, log.info and consumed video uploaded event for movie, right? File, okay, and event dot get movie ID and event dot get original file name. Yes, then let me open my try catch. Okay, exception, and in that let me call the our encode video method. Okay, so encoding service, see, once it is triggered, once the video uploaded event published, it triggered, and what it does is it encodes, so it calls this method. Okay, encode video, right? So encoding service dot encode video, because this is only the method which is responsible to encode our video, and let me pass the event, right? Okay, in the catch log dot error, okay, and failed to process encoding for movie. Okay, and what, event dot get movie ID and e dot get message. Okay, that's it, done. So this is done. Now the next is S3 configuration. Okay, so the same thing, first configuration we have already did it. Okay, and private string, I need what, access key. Okay, I need secret key, and I need the region. Okay, fine, let me fetch it from the properties. Okay, AWS dot access key. Okay, same thing for my secret key, so secret key, and same for the region. Okay, AWS dot region. Okay, fine. Now let's create our bean. So public S3 client and S3 client. Okay, return S3 client dot builder. Okay, dot region. So region dot off, and let me pass our region. Then dot credentials provider. Okay, static credentials provider dot create, and AWS basic credentials dot create, and pass the access key and secret key. Okay, fine, then dot build. Okay, done, and here at bean, at bean, done. Now let us quickly code our properties. Okay, fine. So spring, then application name, so encoding service. Okay, then spring dot Kafka. Okay, Kafka, and bootstrap servers localhost 9092. Okay, and then consumer, so group ID, okay, which is what we have given, encoding service group. So encoding service group. Okay, then auto offset reset. Okay, so it is earliest. Okay, then key deserializer and value deserializer. Okay, so let me just copy paste my serializer and change the name. Okay, so here key serializer and it is key deserializer value deserializer. Okay, org.apache kafka common serialization and string deserializer. Okay, same thing, org Spring Framework Kafka support serializer and JSON deserializer. Okay, done. And then properties. Okay, Spring, then JSON, then trusted, then packages. Okay, fine. And JSON dot, so JSON dot use type headers, okay, false, and the package. Okay, so use, okay, JSON dot value dot default, okay, dot type. So let me pass the our video uploaded event. So this is com.netflix.encoding-service and the entire path dot video uploaded event. Okay, yeah, and now reducer. Okay, so here consumer. Okay, fine. Producer and key serializer. So let me just copy paste, nothing to change. Okay, oh fine, yeah. So key serializer, okay, everything is same, and yeah, that's it. Then server dot port, so 8083. Okay, and then AWS configuration. So AWS configuration same as we did in our video service, this all. Let me copy paste the starting one. Okay, in our encoding service, fine. Okay, AWS access key secret region S3 bucket name, fine. And then we need what? FFmpeg configuration. Okay, configuration, yeah, we need to just provide everything else. Okay, path. So here env, okay, path, and we'll just provide FFmpeg. Okay, and now the temp. Okay, so temp directories, directory for encoding. Okay, encoding, fine. So you know, we have just did this, so we need everything. Bucket name, okay, fine. This FFmpeg path and this base path. Okay, just like what's the base path, so we'll just provide our temp folder. So let's say temp and encoding. Okay, and then it just, you know, yeah, so it adds to this base path, and then whatever movie ID, so it becomes, you know, temp encoding and movie 123. So this is the entire job path, fine. And then all the videos and encoded path. Okay, we discussed already, so we need to provide here. Okay, so encoding, one second, what's that? Encoding and base path. Okay, base path, let me just copy here. Okay, and then what? So temp directory, okay, env, and let's say temp and encoding. Yeah,
fine. And then last is management endpoints, okay, web exposure, include health and info. Okay, fine. So this is done. This is what our application YML. We have included everything, all the properties, AWS files, okay, and I've already mentioned that at the time of testing we'll enter all these keys and secret key and access keys, okay, region and everything else. Fine. For you guys, I hope you have kept your access and secret key file in a secured folder in your PC that we have configured at the starting of the video. Okay, fine. So that's it for our encoding service. Now let's start our streaming service, the last part. Okay, the last part of the video where we'll code to get a streaming URL for a movie on Netflix. Okay, so we'll just check our Redis cache for existing pre-signed URL and some checks, okay, then return the streaming URL. Fine. Also, please don't ask me why pre-signed URL. Already explained while setting up the S3 bucket, okay, because S3 bucket is a private, videos are not publicly accessible, so we need pre-signed URL, okay, which is only accessible to a particular user. If I want to watch something on the Netflix today, so once I click play on some video, I get the pre-signed URL. Using that, my video player, my Netflix player, able to get that particular video from the S3 and serve it to me. Okay, yeah, so already explained in a much detail. Fine. Okay, so without wasting much time, let's start our final thing and then the testing part, full project testing, okay, just like we did in our Uber project. Okay, let's go. Okay, so now in this, just look at here, in this our streaming service consume the event. What event? What encoding service published, that is video encoded event. Okay, so see the flow. At first the video service uploaded the video and publish event video dot uploaded, okay, event published to Kafka. Now our encoding service consume this event. Fine. So encoding done. Now encoding service publish the video encoded to Kafka. The next is streaming service. So streaming service now consume this event. Yes. Okay, fine. So let's start building the skeleton. Okay, let's start with our service dot streaming service, okay, and the another is our consumer. Okay, so video encoded event consumer. Okay, now the next is event. Okay, oh sorry, not the class, it should be package. Okay, so event dot video encoded event, okay, consumes. Fine. Then controller, okay, get streaming URL. So controller dot streaming controller. Okay, so I need a DTO also, DTO dot response streaming response, okay, and configuration. So config dot app config. Okay, fine. Yeah, so let's start with our DTO. Okay, so streaming response, what all fields will include? So first movie ID, okay, movie ID, okay, then we need what we need the streaming URL. pre-signed HLS master playlist URL. So private and string streaming URL. Okay, let me just add comment that pre-signed HLS master playlist URL. Okay, then we need the quality. Okay, fine. So available qualities. Okay, so quality. Okay, available qualities, and then URL expiry time. Okay, so definitely our pre-signed URL has the expiry time so that it can't be shareable permanently. Long and expires in minutes. Okay, fine. Okay, so URL expiry time. Right. Okay, so also let me add data at no args and all args. Yeah, okay. Now let's go to our streaming controller. Fine. So add REST controller. Okay, then add request mapping and its API v1 and stream. Okay, then add slf4j and add required args constructor. Okay, so now first let me private final and streaming service. Okay, then I need Redis template. Okay, so private final Redis template. Okay, string and Redis template. Also I need the master playlist key prefix. Okay, so private static final string master playlist key prefix. So streaming playlist. Okay, fine. Now let's add the endpoints. Get streaming URL endpoint. Okay, so the comments get streaming URL for a movie. Okay, and it returns what? It returns pre-signed HLS master playlist URL. Okay, fine, and it is a get mapping. So what? Movie ID or okay, API, and yeah, that's it. So public response entity. Okay, and streaming response. Okay, get streaming URL. Fine, and add path variable string movie ID. Okay, fine. It is get mapping and movie ID. Got it. Now first let me add some loggings. So it is request streaming request for movie. Okay, and movie ID. Then first we need to get the master playlist key from Redis. Okay, so get master playlist key from Redis. Right, so string playlist key equals Redis template. Okay, dot ops for value. Okay, I already explained
this method ops for value. So all the parameters, all the keywords goes through this method. Okay, then only it applies on Redis. Then we'll get what? Master playlist key prefix plus movie ID. Okay, got it. Now if let's add the check, if playlist key is coming as null, then we'll return response entity dot not found and build. Yeah, else we'll call our method. So what? Streaming service dot get streaming URL. Okay, we'll implement this method and we'll pass our movie ID, and this is the playlist key. Okay, and in return I'm getting what? Streaming response. Okay, response. Fine. And return response entity dot okay and response. Fine, this is what we are returning. Okay, so now let's implement this method in our service quickly. Okay, fine. Now service and required args constructor and slf4j, right? So let me get first private final and S3 pre-signer. Okay, S3 pre-signer. Now private final Redis template okay, string okay, fine, and Redis template. Also I need the bucket name, so let me just get it from the properties. Bucket name, okay, at value, so AWS dot S3 dot bucket name, dot bucket name. Okay, and then also I need the pre-signed URL expiry. Okay, so once we generate our pre-signed URL, a URL which our video player used to play the video, so should have an expiry. Fine, so can't be shareable permanently. That's why we need to add the pre-signed URL expiry. Okay, so private long pre-signed okay URL and expiry. For that too, let's fetch it from the properties. So AWS dot S3 dot pre-signed URL expiry. Okay, that's it. And what? And the Redis key for caching streaming URLs. Okay, so Redis key for streaming URLs. Okay, fine. So private final static string and streaming URL. Okay, and prefix. So let's say streaming URL. Okay, now let's implement the method. Okay, so first in the comments, okay, fine, the steps, the flow, and what, why, everything else. So this method get streaming URL for a movie. Fine, the last step, flow. So first is we need to check the Redis cache, okay, for existing pre-signed URL. Okay, yeah, we need to check in our database. Okay, fine. The second step, if cased, okay, then will return immediately. Okay, third step, if not cased, okay, then we will generate new pre-signed URL from S3. Okay, 4 is cache the URL in Redis. Okay, and then fifth is simple, return is streaming URL. Okay, so self-explanatory. Okay, let's do one by one. Also if some of you might ask, like, why pre-signed URL. Okay, so for that too, let me add few comments. Okay, so S3 is a S3 bucket is private locker room. Okay, like videos are not publicly accessible, right? So what? Pre-signed URL gives temporary, just look at here, temporary, okay, access, maybe some X minutes, okay, fine, and it prevents unauthorized video downloads. Okay, otherwise anyone can download, so the Netflix security breached. Okay, not secure platform in that case. So public and streaming response. Okay, fine. Get was that get streaming URL, and I'm getting the movie ID, I guess, and playlist key. Okay, playlist key, fine. Okay, so first let me add log.info, and I'm getting a streaming URL for movie. Okay, and movie ID. Then first let me get the cache key. Okay, so is streaming, what's that? Yeah, streaming URL prefix plus movie ID. Okay, and then we need first what? We need to first check Redis cache for existing pre-signed URL. Okay, like if there is any, fine, like if this is not the first time, then so check Redis first. Okay, so a string URL cached URL equals Redis template dot ops for value and apply get method get, and this is what the cache key. Okay, fine. Now if cached URL, okay, not equals null. Okay, if not equals null, right, then what? Then we will return the streaming URL for that movie. Okay, log.info and returning a streaming URL for movie. Okay, and movie ID. Okay, fine, and
return new streaming response, okay, and streaming response. So movie ID, streaming URL, and quality. Okay, so for all quality, right, like the available qualities we have set as all the 1080 and till 360. Okay, fine. So the first is what? The first is movie ID streaming URL. 1 second, you just come here. Okay, oh, where is that? Service, streaming service. Okay, so first is movie ID. Okay, so let me just set the movie ID. Then streaming URL, so this is what our cased URL. Okay, fine. Then quality, so all qualities, right? So till 1080 pixel and 720 and 480 and 360, right? And then what? Expiry in minutes. Okay, so yeah, this one, pre-signed URL expiry. Okay, fine. Okay, yeah, quality and all. Okay, you just go and please come, sir. Okay, yeah. So now next, what next? The next is generate. So okay, so if cased URL comes as null, then what? Then we need to generate new pre-signed URL from S3. Okay, so generate pre-signed URL from S3. Okay, that is why I'm just writing comments before every implementation. Okay, so log.info, generating new pre-signed URL for movie and movie ID. Okay, and then we will generate our pre-signed URL. Okay, so for that we'll create another method, generate pre-signed URL, and we'll pass this playlist key. Okay, we'll create this method. Okay, implement it. Fine, this is done. So generated. Now yeah, so we'll cache in Redis for 55 minutes. Okay, why 55 minutes? So 5 minutes, suppose our expiry pre-signed URL temporary access. Okay, so suppose expiry is 60 minutes, let's say 60 minutes. Okay, so then we'll cache in Redis for 55 minutes. Why 5 minutes less? 5 minutes less than actual expiry to avoid the edge cases. Okay, what it means, let me explain the entire thing. Okay, just look at here. Fine. So what it means is cache in Redis for 55 minutes. It means we want the URL should stored in our Redis for 55 minutes. And why we want that? Okay, just look at here. Okay, so fine, and this too, fine. Okay, so this is, suppose this is my S3. Okay, and S3 is responsible to generate the
pre-signed URL. Okay, generated, then cached in Redis. Okay, that means stored in Redis. So URL and Redis. Okay, now our end users, all the Netflix viewers, once they click on the play, okay, for any content, so it requests this URL. The video player requests this URL so that it plays, the video whatever viewers want to watch. Okay, this is the complete flow. Now we have kept, okay, we want that it should cache in Redis for 55 minutes. Cache means should stored in the Redis memory for 55 minutes. The expiry time we have decided as 60 minutes expired from the S3, but we want it should removed from Redis at 55th minute itself. Okay, why is that? Okay, because to avoid the edge cases, let me explain you. Suppose let's consider the entire scenario and with the 60 minutes. Okay, so same S3, okay, same URL generated, pre-signed URL, fine, then same Redis cached the URL, okay, Redis, fine, and same this Netflix player and our users. But now we remove this concept that 55 minutes. Okay, fine, so the URL expiry is 60 minutes, and fine, once the URL expired, so at that time it removed from the Redis itself. Okay, 60th minute. But is that making some sense? Like these are my user. Okay, these are my users. Now user clicks on the play button, fine, okay, the video is running, so from 0000 till okay, and suppose there is a 3 hour video, so at this is the 60th minute. Okay, fine. Now what? As per our coding, let me just show you what we have did. Okay, fine, so we are checking our Redis cache first. Yes, we are checking the URL in our first Redis memory. If our Redis cached, okay, is not null, that means we will return that. Okay, yeah. Now just for the same, just look at here. Okay, yeah, okay, let me bring back. So if the URL, if a user wants to request a URL, okay, that means player wants to request a URL, so first it checks with the Redis cache. That's what we have written here. Okay, if it contains in the Redis, then it will return it, the URL, and video continues. Okay, next what we have coded is, so if cached URL becomes null, if it is not null, then return that what's stored in the Redis. If it is not if it is null, then come outside and generate pre-signed URL again from the S3 here. Okay, so one second, let me bring back. Okay, so if in the Redis it become empty, okay, if it is removed, then from the S3 generates again, okay, and new URL, okay, new URL, fine, for that again 60 minutes expiry in the S3, then cached, that means again stored that new URL in the Redis, and then player requests that new URL and video continues further. Yes or no? Yes. Now what is the error? Like what is the mistake with 60 and 55 minutes? So if we kept the URL in Redis for 60 minutes, okay, that means what happened is let me just scroll up. So what happens is this is suppose my video player, okay, and video is running. So suppose here is a 60-minute, and at 59th minute, a player or user request a streaming URL. So it asks again the Redis. Yeah, same code runs fine. So first it check the Redis. Now if we kept the URL in the Redis for 60 minutes, so at 59th minute the same old URL is there. Okay, because in the Redis also it will get removed at 60th minute. Okay, so fine, it will return that same old URL. Until that, if the 60th minute done, okay, if the 60th minute done, then it get already expired from S3. Expired. Fine, results in video failed. Okay, failed. So that is why we have kept, this is the video, this is the 60th, and this is the 59th minute. So we have kept the Redis. This is my Redis, and URL should removed from the Redis at 50th minute. So suppose at 54th minute it checks, okay, it asks for the streaming URL from the Redis. Okay, at 54th minute it is there, the old URL is already there, it returns it. Fine. At 55 minute the URL removed. Yes. Okay, so our code checks that okay, URL removed, coming null. So now at 56th minute it will generates a new URL from S3, and still we have 4 to 5 minutes. So updates that URL in the new URL in the Redis. Okay, and from that another 60-minute expiry. So this goes on till the video end. Yes or no? Understood? This is what the complete scenario. Okay, I hope you got it. Fine, so let's move forward. Okay, so Redis template dot ops for value, okay, and dot set. Fine, so cache key and pre-signed URL and offset 55 and time unit dot minutes. Okay, fine. Also let me write the log. So log dot info and streaming URL generated and cased for movie and movie ID. Fine. Okay, now we need to return new. Okay, so streaming response and movie ID, then pre-signed URL, okay, and then qualities. Okay, so 1080 pixel, then 720, then 480 and 360, okay, pixel. Fine. Okay, and 1 second. Oh, pixel and pixel. Fine. And pre-sign, yeah, URL expiry. So this is done. Now we need to implement this method. How we'll generate a pre-signed URL. Okay, so let me add the comments first. Generate a pre-signed URL for S3 object, okay, and URL expires after configured time. Fine. So private string and generate pre-signed URL, and I'm getting the key. Okay, so playlist key. Okay, 1 second. Fine. Okay, so key, fine. And now get object request. Okay, so get object request. Okay, get object request equal get object request dot builder and bucket, so bucket name, then key and build. Right, now we need to get object pre-sign request. Okay, get object pre-sign request. Okay, pre-sign request equals get object pre-sign request dot builder, and then for signature duration, so duration dot of minutes, and what, pre-sign URL expiry. Okay, then get object request, so we'll pass get object request. Okay, and then dot build. Okay, fine. Now let's return S3 pre-signer. Okay, dot pre-sign get object, so pre-sign, yeah, pre-sign get object, and we'll just pass the pre-sign request dot URL and dot toString. Okay, done. Fine. Now we also need to just add one more method, that is to invalidate cache. Okay, so in case invalidate cache is streaming URL. Okay, and it is called when video is re-encoded or updated. Okay, yeah, so public void invalidate cache. Okay, and a string will pass the movie ID. Okay, so a string cache key equal is streaming prefix plus movie ID. Okay, and then Redis template dot delete. Okay, invalidate with that. Okay, so yeah, fine. And then log.info, so we'll write streaming URL cache invalidated for movie ID. Yes, okay, so our streaming service is done. 1 second, I have added just one method, right? Oh, so we need the signed playlist also. Yeah. Okay, it's not done yet. Okay, one more method. Fine, so it's like public response entity. Okay, and a string get sign playlist. Okay, yeah, get sign playlist and add path variable. Okay, a string movie ID and add request param. Okay, a string path. Yeah, also let me just write the comments. Okay, so serve signed M3U8 playlist content. Okay, and it is called by Netflix. Okay, so HLS player for each quality. Okay, because the playlist files is present in the each quality folder. Okay, and we need the signed playlist, otherwise what we'll get the error like unable to play the video. Okay, that is why. Okay, so this is what called by player for each quality playlist. Okay, yeah, the important thing, then a string sign playlist equals a streaming service. Okay, streaming service dot get sign playlist. Okay, and let me pass the movie ID and path. Okay, so we'll create this method and then we'll return the response entity dot okay, then header. Okay, so content type, one second, content type. Okay, and application. Okay, FFmpeg URL. Fine, and dot body. So it is sign playlist. Yes. Okay, now let's implement it. Okay, so it is get mapping. Okay, playlist. Okay, fine, movie ID and playlist. Okay, let's implement this method. Fine, so in our streaming service, after this, okay, public a string get sign playlist, and I'm getting a string movie ID. Okay, and a string playlist path. Fine. Okay, so first I need the base path for the playlist. Okay, so get base path for this playlist. Okay, so a string base path equals playlist, playlist path dot substring. Okay, and 0 comma what, playlist path and last index, okay, of the slash plus one, right? So dot last index, see it is auto populating plus one, right? Okay, fine. Now I need to read the content, so read M3U8 content from S3. Okay, how to do it? So M3U8, okay, and content, fine, nice variable name. Okay, and how to read? So for that also let's create a method read from S3. Fine, so we need to read from S3 and then serve to the user. Okay, fine, playlist path. Okay, so we'll create this method, we'll implement it. Next, what we need is we need to rewrite each line that is a segment chunk, okay, or playlist reference. Okay, so sign content. So for that also we'll create a method rewrite M3 and U8 sign URLs. Okay, we'll pass M3 U8 content and base path. Okay, fine, then we'll return our sign content. Okay, fine, so let's implement quickly these two methods. Okay, first this method rewrite M3 U8 sign URL. Okay, plus before it, let me just write a most important comment that this is the key method that makes everything secure, and that is what our topmost priority. Fine, so let's implement the method private string. Okay, and I'm getting what, M3 U8 content and base path. Okay, fine, now let me just take the string builder. Okay, and rewritten equals new string builder. Okay, and now let me just we need to rewrite. Okay, so for each loop is string line, and from the m3 content, okay, m3 content, m3 uid content dot, and let's split. Okay, fine. So string trimmed equals, we need to just trim each and every line first, dot trim. Okay, also if there are empty lines or comments, we need to skip that too. So skip empty lines and comments. Okay, so if trimmed dot is, okay, if trimmed dot is empty, okay, or trimmed dot starts with, so comment, that means it should starts with hashtag, then we need to return dot append line, okay, then dot slash n, okay, slash n, fine, and then continue. Okay, else what, else this is a segment or playlist reference, and build full S3 key and sign it. Okay, sign it, important one. Now string full key equals base path plus trimmed, okay, fine, and string signed URL, okay, this is our signed URL, equals generate pre-signed URL, okay, and we'll pass the full key. Okay, yes or no? Yes, fine, and then return dot append signed URL and append slash n. Okay, we'll return dot toString. Okay, yeah, dot toString, fine. Okay, so now next method, that is read from S3. Yes, okay, so let me write the comment. Oops. Okay, read file content from S3. Okay, fine, private string and read from S3, string S3 key, right? Then okay, so let's build the request. Get object request, and request equals get object request dot builder and bucket name, okay, so bucket name, right, then key, okay, I'm getting S3, okay, and then build, okay, build, fine, yeah. Now response input stream, okay, response input stream, and of type get object response, okay, yeah, response equals S3 client, okay, S3 client, okay, fine, let's create it. Private final S3 client, okay, S3 client, let me copy this, yeah, dot get object, okay, and request, fine. Okay, next is we need to return new buffered reader, okay, and input stream, so new input stream reader, okay, definitely, okay, we are reading, okay, so response, fine, then oops dot lines and dot collect collectors dot not set joining and delimiter as /n. Yes, okay, fine. So that's it. So what we have did is, okay, so we are reading m3 UAT file from S3 and rewrite all. Okay, and segment URLs with pre-signed URL. What? Pre-signed URL. Okay. 1 second. So where is that? Yeah. Okay. Yeah. So this is what now it is done. Our streaming service is, fully completed. Okay, so now let's quickly finish our consumer and other files like app config and video encoded event resources, and then final full project testing. Okay, let's do it.
Let's go and finish our consumer part. Okay, consume the encoded event. Okay, so first add service at slf4j at required args constructor. Okay, fine. So now first private final and Redis template. Okay, string and Redis template. Okay, then also we need private static final string and master playlist key prefix. Okay, which is what? Streaming streaming playlist. Okay, yeah. Now what? The comments are really important. So what it does is it listens to video.encoded Kafka topic, okay, and stores master playlist key in Redis when encoding is complete. When encoding is complete, obviously, okay, and this allows a streaming service to quickly find the playlist key by movie ID. Okay, fine. Yeah, let's start it. So public void and consume. Okay, so consume what? Video encoded event. Okay, and yeah, obviously video encoded event. Okay, fine. Also fine, let's do it. So video encoded event, where is my encoding service? Okay, and event video encoded, let me just copy paste. Okay, yeah, here. Fine, I don't need these comments. Okay, already there. Okay, and add data, add no args and add all args. Okay, also comments here too. Fine, so consumed from Kafka topic video dot encoded, okay, and published by encoding service after FFmpeg processing. Okay, now so what? Add Kafka listener. Okay, and first topics, so what? Video dot encoded, okay, and group ID. So a streaming service
group. Okay, fine. Now let's add some loggings. So log.info and consumed video encoded event for movie. Okay, success and event dot get movie ID and event dot is success. Okay, fine. Now 1 second. Yeah, okay, so let me just first check if event dot is success. Then we'll store master playlist key in Redis. Okay, so a string cache key equal master playlist key prefix plus event dot get movie ID. Okay, as you already did, and Redis template dot ops for value dot set the key and event dot get master playlist key. Okay, and log dot info. So master playlist key is stored in Redis for movie. Which movie? Event dot get movie ID. Yes, okay. Else what? Else error. So encoding failed for movie. Okay, and event dot get movie ID not success message dot get error message. Okay, yeah, error message, this one. Okay, fine. So with this our video encoded event consumer is done. Now the only thing remaining, that is configuration and properties file. So let's do it quickly. So configuration, okay, and we need to create the beans. Okay, so first same thing, we need what? Few things: a string access key, okay, private string secret key. Okay, 1 second. So where is config, S3 config? Let me just copy and paste app config here. And okay, next to yeah, okay, same thing, S3 client. Okay, fine, region access and secret key. Okay, then next, so I guess we have, in the where, yes, S3 pre-signer. So our streaming service and config app config and yeah, S3 pre-signer. Okay, yes, and the third bean will create, that is for the Redis template. So public Redis template, okay, and a string Redis template. Okay, fine. So Redis connection factory, okay, and first 1 second, so Redis template, okay, a string template equals new Redis template. Okay, then template dot first set connection factory, so Redis connection factory. Okay, and then template dot set key serializer. Okay, so it is new string Redis serializer. Okay, and now value. So template dot set value serializer. Okay, new string Redis serializer. Okay, and return template fine bean. Okay, so this is also done. Now only thing remaining, that is our properties file. Let's do it. Fine. So Spring application name is streaming service. Okay, and then what? Redis. So Spring application data. Okay, then Redis, then host local host. Okay, and port. So it is 6379. Okay, 6379. Yeah. Now spring dot Kafka dot bootstrap servers. Okay, same thing, localhost 9092 and group ID. So group ID is what? Streaming service group. Okay, and then auto offset reset earliest, then key deserializer. Okay, so let me just copy and paste. Key deserializer. Fine. Okay, now yeah, string deserializer, JSON deserializer. Okay, next is same thing. Okay, so properties and here and till here. Okay, and here we need to provide the video encoded. So video encoded event path com.netflix stream service dot event. Okay, and video encoded. Okay, yeah, that's it. And then server dot port, so 8084. Okay, then AWS configuration. Okay, so let me just copy this to till here. Okay, streaming service, fine. And also S3. So here where S3 pre-signed URL expiry. Okay, this AWS S3. So AWS S3 and here pre-signed URL expiry, so 60 minutes. Okay, let me just write it. Pre-signed URL expiry in minutes. Okay, fine. At last, management. Okay, endpoints, then web, then exposure, and include health info. Okay, so with this we have completed our entire Netflix project. Entire Netflix application is fully done. Now we are moving to the next important phase, next crucial phase, or I can say next important part, that is our testing. Why? Because it decides whether our application is ready for the
production or not. That is what our main goal. Yeah, so that is why the testing phase is most important, or I can say only important part, topmost. Also this is the first thing. Okay, the second thing is, you know so while testing, definitely we'll get errors in any of the services or anything we missed. So we'll rectify those error there itself. We'll get to know that okay, this is the place we can make errors. We'll rectify the errors. Okay, then we'll resolve it. Again, if we'll get error, then again we'll resolve that errors till our application passes all the test cases and becomes ready for the production. Yes or no? This is why the most important phase, testing. Yeah, after that people, normal users can easily use our application. I mean, they can easily stream their videos on our Netflix project. But before we need to test it, we need to test like the streaming is going smoothly or not, okay, available qualities or not, 180 1080 pixels till 360 pixels, okay, everything else fine. So let's test our application and finish the job. Okay, now before I run my all the services, make sure you enter your username password, okay, in our content service, and in rest of all the services make sure that in our application YML you have already filled the access key, secret key, region and S3 bucket name with the correct values, just like bucket name. So just let me go there, and this is what my bucket name. Okay, let me just copy it and paste it here. Okay, now the region. Okay, so region is, can you just watch clearly the URL. Okay, so the first part for me it is Europe. Okay, EU hyphen not hyphen 1. Okay, so let me just yeah, okay, copy it here. Fine, later on we'll just set it the env variables. For now you can just copy the values. Yeah, and for the access key and secret key, okay, I guess you have already downloaded the access key, secret key at the time we are setting up them. Okay, so just copy and paste it here. Okay, let me also do the same. Fine, I've added the values in all the fields of AWS like access key, secret key, and I hope you have did it the same. Also in every services required, okay, like in the encoding service, in the streaming service, video service, okay, we need the AWS credentials. So I hope you have did it the same. Okay, let me just close all tabs and now let me start the services one by one. Okay, also in the content service, the MySQL, that username password. Okay, fine, let me just click on the run and our service starts. Okay, fine, on the port 8081, and it will create a movie table, okay, in our database. Yeah, can you see create table movies? Okay, fine, so let me go to my MySQL and now hit show tables. Okay, so initially it is showing empty set. Okay, now movies, one table created. Okay, fine, now let me start another service. Okay, another service, that is next is video service, right? A content service, then video service. So Java video service run. Okay, then fine, let it run. Okay, start it. Yeah, so it is running on the port 8082. Okay, fine. Yeah, started video service. The same way we'll start our encoding service. Okay, encoding service, fine. 3 2 1 and go. Okay,
So our encoding service is running on the port 8083. Yes, yeah, 8083. Okay, our encoding service also started fine, and then the last is our streaming service. Yeah, so run. Okay. Fine, 3 2 1, let's go. Okay, and our streaming service is running on the port 8084. Yes, okay. So I'm getting a gut feeling that definitely will get some errors, and I want it so that we can rectify here itself. Okay, started streaming service. Fine. Now what? The first thing is, let me open my Postman. Okay, so already kept open. Fine. And the first thing is we need to add a movie. Yeah, so let's go with the flow. The flow is first content service job. Okay, that is first add movie in the catalog. Okay, then video service. So we'll hit the controller from content service, then video service. Okay, because that is only when we'll get the movie ID, and movie ID is the most important parameter in our entire Netflix project. With the movie ID we'll upload that movie to S3, then encode, then stream. Okay, so let me just go to the content service. Okay, and content controller. So first add movie. Okay, API v1 movies and localhost post mapping localhost 8081. Okay, API v1 movies, right? Okay, and movie request. So title, description. Okay, fine, this is what we need to pass. Okay, so in the body raw JSON. Okay, and 1 second, title. Okay, so let's say the movie title is test movie. Okay, test movie. Fine, then description is, let's say, a mind bending thriller. Okay, then what? Then genre. Okay, so let's say genre. Okay, fine, so let's say science fiction. Okay, then what? Movie request, right? Movie request, then director, cast and release year. Okay, so director, let's say my name. Yeah, and cast. Okay, again my name. Okay, then release year. Okay, release year, so 2025. Okay, then what? Rating, thumbnail rating double, thumbnail URL and duration in minutes. Okay, so rating, okay, let's say 8.8. fine, and thumbnail URL. Okay, so test movie and thumbnail url.com, and the last is duration in minutes. Okay, duration in minutes, so let's say 148 minutes. Okay, fine, now let me send it. So send the request, sending the request. Oh, put it is post mapping. Fine, and yeah, so I'm getting an object. Let me just go here, content controller, and I am returning movie response. Okay, all these fields. Fine, so this is what the ID I need. Okay, title, description, whatever the values we have given, and I want you all to focus on 3 fields: video key, video status and HLS URL. Okay, for now currently video status is pending, definitely. So video status is pending. Yeah, in the first value in our flow. Now if our video service uploads the video, then status changes from pending to uploaded. Okay, let's do that. Yeah, let's do that. Our next video service src main java and controller, video controller. So upload movie. Okay, upload movie, and this is what. Okay, it is running on the port localhost 8082, and yeah, the next is upload and movie id. I need to pass movie id, so I got the movie id here. Yeah, okay, fine. Now what? I also need to pass the video file, yes or not? So if I am uploading, if suppose I am the director of the movie and I am uploading the movie on the Netflix, okay, so I need a raw video file, yes or no, so that I'll upload it. Yeah, so that is why we are accepting a multi-part file. Okay, file. So for that I already downloaded a small file in my file explorer. Let me upload that only. Okay, let me go to my postman, and here you need to just first select the post mapping body, and here form data. Okay, form data, just type here file file, and here from the drop down select file. Okay, so here is the option select files. Okay, so let me just select the files. Okay, and this is what a test video I already downloaded. Okay, so this is what our movie, and this we are going to stream on our Netflix application. Okay, let me just show you by playing our video. Okay, so this is just a small nature video. So this is what our movie, and we are going to stream it on our Netflix project. Okay, fine, let me just select it. Can you see test video.mp4? Fine. Now one more thing, now all your eyes on should be on encoding service. Okay, because this is what our video controller video service. Once the video is uploaded to S3, we are publishing event to Kafka, and encoding service consume this event. So definitely in the encoding console we'll get the loggings like the event consumed. Okay, fine. Okay, and also yeah, so the video key is like raw hyphen movie id and random id and the original file name. Okay, so this is the format. So I want what I want in the movie entity my video key to be get updated. Yes or no? Yes. Okay, so in our movie entity we have two fields, video key and HLS URL. So once the video uploaded, that is the job of video service. Once the video uploaded, then video key should be updated. Okay, and once the encoding finished, then we'll get the HLS URL. So after that, the HLS URL also get updated. That is why we created these two methods, right? In the service, content service, and yeah, these two methods, update video key, update HLS, and with that only we are updating the status like uploaded, ready for the stream. Yes. Okay, now there is one error here. Okay, and I know if you point it out in the comment box, or no worries, but I want this error so that we can rectify here itself. Okay, so all eyes on encoding service, and let me just upload this, upload, send. Okay, so sending request, and let's, yeah, can you see video uploaded successfully? And this is what raw hyphen and the format. Yeah, at last test video.mp4. Okay, and encoding started automatically via Kafka. Let me just go there. So encoding. Okay, so starting encoding pipeline for movie. Okay, this is what I got. Consumed video uploaded event. Okay, this is in the encoding service. Consume the event, started raw video downloaded to this. Okay, 1 second. Temp encoding. Okay, so here we have one error. Instead we'll give some, this is suitable when the system is Linux, I guess. Better, because at the end unable to find the access key, so better we'll give the path for our existing path like C temp encoding. Okay, fine. The next I can see encoding failed for the movie, cannot run FFmpeg. Oh, I got it. Also let me just go there and let me check whether my fields are getting updated or not. Okay, so this is, we get to know that our encoding failed. Fine, but our video uploaded. Okay, we can see the status like raw video uploaded successfully. So let me just go to my S3 and check it. Refresh this, and I guess one folder only. Yeah, one folder. Okay, in that raw folder, fine, ID, and in that we have this test video.mp4. Fine. Why only one folder? Because encoding failed. That is why only one folder created. So we are creating two folders. One folder is raw folder, which contains our entire raw video file, what I have shown you. Second, here there one more folder, that is encoded, which contains the chunks, segments, master dot m3 uat file. Okay, which is responsible to stream the video. So that is failed to create because definitely our encoding failed. So that is what we need to rectify. Okay, let's do it. So this is what confirmed, that uploaded. Fine. Yeah, also I'm checking one thing. Okay, content controller. Let me get the movie. Get movie by ID and by movie ID. Okay, so same 8081 API movies, get movie by ID, and let me just paste the ID here. Okay, fine. Now I'm getting the movie. Okay, so what I want is send. See, can you see this? Is still the status is pending, null, there is no video key updated, and definitely HLS key will not upload because encoding failed. But video already uploaded. We got this S3 key. This is what only the S3 key. Okay, so at least I need my video key to be updated in the movie object, but that too failed. Plus status also is still pending. Okay, like uploaded but still pending. Get a point? And we have created this method update video key. Okay, so this is not being hit. Okay, because here only we are changing the status. So the error is, I guess, 2 to 3 or 4 errors. Okay, the errors, the first error, let me just show you. Yeah, 1 second. Okay, video service. So we have created these two methods, okay, to update those two values, video key and HLS URL, but we haven't created the consumer. Okay, consumer. Once video service uploads the movie to S3, okay, upload movie to S3, yes or no? Now what? We'll get the video key. Then I want my content service consume this event, like video.uploaded event, and then get the video key and update here, just like our encoding service is consuming. Getting my point? So we haven't created any consumer. Similarly, once encoding is finished, we'll get HLS URL. So again, I want my content service consume this event, video.encoded event, and update this. Call this method HLS URL. Okay, and then update the status as status ready. So this is what our first error. Okay, let's move to our second error. Fine. The second error is, you just close. The second is encoding failed. Why failed? Because encoding, and in the resources, yeah, here in the FFmpeg configuration, we need to provide the FFmpeg build path. Okay, we forget that. Fine, what is this FFmpeg? Just a text. Okay, no, it not works here, definitely. So we need to provide the FFmpeg build path. For that we need to download that FFmpeg release build and provide the path like c ffmpeg bin, then ffmpeg.exe, just like that. Okay, and the second thing is we also need to provide the temp directory path. Okay, like c temp directory, then recording and encoding in that. Okay, so this is our third or fourth error. Let's rectify each of them one by one. Okay, so let me do it quickly. The first thing is content service. Let me create the consumer in our service. Okay, Java class, and what, video uploaded encoded event consumer. Fine, because see, here is a crucial point. It's not the consumer like we have created in the encoding service main Java and service video event consumer. So we created the consumer, okay, which contains just one method and consume this event, video.uploaded topic event. No, our content service consumer should have the capability to consume both the events, video.uploaded, video.encoded. So once video service uploads, our content service consume and update the video key. Once encoding service encodes, got the HLS URL, content service consumes and update the HLS URL in our content service movie entity, video key HLS URL. Yeah, now there is again a confusion. Okay, what the confusion is? The confusion is if there is, let's say, only one, if in our consumer job is to consume just one event like video.uploaded, video encoded, then it is fine. We can enter the group ID. Now our content service need to consume the event from two different services. Okay, so what can be the group ID? Yeah, what can be the group ID? How it is possible? So we'll use the hash map, okay, payload, get the everything from payload and send it. Okay, just watch here. Okay, you can just code with me, close all tabs, and let's start coding this. Yeah. Okay, so first let me stop all the services and quickly let's start. So service, okay, and what, add slf4j, okay, and add required args constructor. Fine. Okay, then let me just private final and content service, okay, because I need to call those methods, and then let's start. So public void consumer video uploaded event. Okay, so first uploaded, so we'll use the payload. Okay, oh, one second, we have not added the dependency, that is Kafka dependency, in our content service. So first let's add that. Let me copy from other service and my form.xml. okay, here Kafka, welcome Kafka, and let it load the form.xml. okay, yeah, so just few more seconds and I guess it is done. Okay, now payload, yeah, then we'll use the map. Okay, so a string and object payload, okay, fine. Now let's get the movie ID and video key. Okay, consumer video uploaded event. So a string movie ID equals payload, okay, dot get movie ID, okay, dot toString, and a string video key equals payload dot get video key dot toString. okay, fine. Now log dot info and video uploaded to for movie, okay, and the key movie ID and video key. Done. And then let me call content service dot update video key. Okay, let me pass here. Now here at Kafka listener, okay, and topics, so video dot uploaded, okay, and now here we used to write the group ID, okay, but no, will not write. Okay, fine, because we need to consume two events from different services, so we'll manage it in our application.yml. okay, fine. The next is our consume video encoded HLS URL. okay, so public void consume video encoded event, okay, same thing, add payload, so yeah, here add payload, okay, and then let me get the movie ID, okay, then let me get the HLS URL. okay, so fine, a string HLS URL equals payload dot HLS URL dot toString. Also let me just success equals payload dot get success, okay, and what, fine. Now let's check if success, okay, if success is like it's true, then content service dot update HLS URL, okay, if not, here if not, okay, so a string error message, okay, equals payload dot get error message dot toString, and also we need to create one more method here in the content service. Okay, public void update video status. Okay, I'm getting the movie ID and video status. Okay, video status. Fine. So first let me get the movie, and then what? Movie dot set video status and then save it. So movie repository dot save movie. Yes, so it helps to update the status as failed. Okay, otherwise how will update if something got failed? If something got failed, then it will be in the pending state until and unless we'll create a method for that. Okay, yeah, definitely we are building the Netflix real world project, so we need to provide for each and every services. Content service dot update video status. Okay, first is movie ID and then video status dot failed. Done. Here at Kafka listener and topics, so video dot encoded. Okay, now let me just go to my application YML and update other things. Okay, so Spring and then Kafka, Spring Kafka. Okay, then bootstrap servers. Okay, so local host 9092. Fine. And then consumer, so group ID equals, so here we'll provide a common group ID as content service group. Okay, and then auto offset reset. Okay, reset, so earliest. Fine. Then deserializer, so let me just copy paste. Okay, key deserializer. Okay, also entire thing. Yeah, so key deserializer string and JSON deserializer, and here not a particular event, instead we'll provide what we are using, that is java.util.hashmap. Okay, fine, it's done. Okay, it's done. So now the next thing is, let's rectify our other errors, that is encoding service. So here first we need to download the FFmpeg release build. Okay, so I already did it. Let me show you how to do that. So let me go to my browser. Okay, and then copy this URL. Okay, yeah, codex FFmpeg. Don't worry, I've already pasted this URL link in the description. You can just go there. Okay, and scroll down. So here can you see release builds? Here you can just download this one, FFmpeg release essentials.zip. Unzip it. Okay, and then extract it. Fine. Okay, and then put it in your C folder or wherever. Okay, so I have just pasted it in the C folder. Let me show you here my C folder, and can you see this FFmpeg? Okay, here I've extracted. This is the bin and this is the FFmpeg. So we need to provide this path. This is the .exe file. Okay, so let me just copy this and go to my and C / and FFmpeg.exe. Okay, for this too, let me provide C temp and encoding. Yeah, okay, explorer path. Fine. Also I can't see the logs of processing. Okay, so for that we need to add one more line. Okay, Java service encoding service, and scroll down. Yeah, here encode to HLS. So before start, we need to, just add process builder dot inherit IO. Okay, it enables the console logs. Okay, like we can able to see what processing is going on in the backend. When our 1080 pixel processing done, encoding done, when 360 done, when 720 done. Okay, just like this. So I guess everything is done. Okay, again let's start our application and rerun it, retest it. Yeah, see, this is what the beauty. We got the error, resolve it. Again got the error, resolve it. Okay, so again let me start each and every services one by one. So content service, okay, let's start. Fine. Let's wait for a few seconds. Okay, fine. And then video service, encoding and streaming. Okay, so yeah, starting on the port 8081 and quickly let's start. Okay, and then encoding video service. Okay, starting and fine, started content service. Yeah, okay, yeah, done. Next is encoding service. Okay, sorry, video service. So let me start the video service, run. Okay, video service application is up and running and started on the port 8082. Okay, fine, started quickly. Yeah, done. The next is encoding service. So encoding. Okay, encoding service. Okay, it is starting. Yeah, so started on the port 8083. Okay, and then the last is our streaming service. Okay, and streaming service. Fine, so quickly let me just, okay, first let it start. Okay, so now let me go to my Postman and again add the movie, right? So yeah, okay, let me copy this movie ID and again upload this video file. Okay, so send it and what, video uploaded successfully, I guess. Okay, 3 2 1. Yeah, now let me go back to my encoding service console. Yeah, this is what I wanna show you. Can you see these console logs? Okay, it tells us the FFmpeg processing. That's why we added this line process builder dot inherit IO. Okay, so can you see this 1080 pixels and their chunks segment with playlist.m3 UAT file. So now our processing is going on. That means for each quality, chunks is being created. The video is being getting cutted down in 10 to 12 second chunks. Okay, so just like it will create for all the qualities we provided, that is 1080, 720, 480 and 360. Okay, fine, and then our streaming service consume this encoding event. Okay, and then we'll get the streaming URL. Okay, fine, so let it finish it. So now 720 pixel started. Okay, and our yeah, encoded 1080 pixel successfully. Fine, so now 720 pixel started. Okay, chunk 1, chunk 2, chunk 3, and that's it. Okay, fine, so how long your video is, that much amount of chunks created. Okay, 10 seconds, 12 seconds, right? Okay, so now 480 pixels. Okay, and then now 360 pixels. Okay, so let it finish and then yeah, encoded 360 successfully, master playlist generated. Let me go to my streaming console, and here we expect to see that consume event video not encoded, okay, something like that. So till then let me just hit that URL. Okay, 1 second. Okay, so which one? Our local host 8081. Okay, and I need the movie by ID. Okay, so let me get this movie by ID. Okay, can you see this? Can you see this? Once uploading finished, I got the video key, and video key uploaded in our movie field, movie entity video key field. This is. Once encoding also finished, okay, we have seen encoding also finished, I got the HLS URL, and I got the HLS URL value filled in our movie entity, that HLS URL field. Now the only thing remaining is let's test it out. But before, let me go to my AWS console. Okay, and let's refresh the objects. Okay, can you see this? Raw and encoded. Okay, so as we discussed that raw folder contains our raw video file. Encoded folder contains chunks, okay, or segments for each quality. Okay, let's see. Okay, let me show you. Go to the encoded. Okay, fine. And can you see this? All the folders, 1080 pixel, 360 pixel, 480, 720, and our master playlist file. In that contains the chunks which is responsible to stream the video. Okay, now I know you are waiting for the moment that we stream our video just like Netflix is doing. Okay, let me go to my IDE. Okay, and streaming controller. Okay, fine, and API v1 stream. Okay, localhost 8084 and API v1 stream. Fine, and let me hit with the movie ID, movie ID. Okay, yeah, get it? Okay, I got the streaming URL. Let me click on it. Can you see this? The streaming URL contains lot of parameters. So HMAC, okay, dates, sign headers, and expire 60 minutes, a secure URL. Now if let me copy it and paste it on my browser, what happens? Okay, so the video is not running. Why? Because see, it will not run definitely if let me just go to my raw and our video file. Okay, this is the entire video file and our object URL. Okay, just hit this link. Can you see this? Access denied. Yeah, access denied, definitely. It will not run. Okay, so for that we need to build the Netflix player. Okay, don't worry, I've already built it using a simple HTML, CSS, JavaScript. In that we just need to provide the movie ID. In the backend it is taking and running our streaming URL. Okay, Redis cache. Fine, so let me go to my file explorer, and here is my player. Okay, Netflix player. Fine, let me just copy the path, copy as path. Okay, and yeah, okay, fine. Yeah, so this is a simple HTML, CSS, JavaScript magic. Okay, streaming platform, Spring Boot, Kafka, AWS S3 here. paste I need to just enter the movie ID from the content service, and here is our Netflix. So consider it as a Netflix player only. Okay, yeah, there is a lot of designs need to change, but Netflix player to the production. Okay, now let's test it out. So I just need to get the movie ID. Okay, everything is done, processing, encoding, and should I hit the play? Okay, should I hit the play? Fine. 3, 2, 1, go. Okay, fine. So stream loaded, but still okay. Loaded. So yes. So this is what we want. This is what our hard work, past 4 to 5 hours hard work, and the video is streaming. This is only the video I've shown you, right? This is only the video we uploaded. Okay, so for that let me delete this video, okay, from the file explorer, right? So file explorer, and yeah, this is the video. Shift delete, permanently gone. Again, let me go to my browser and reload this. Okay, then again let me just copy this movie ID, okay, and paste it here. Play it, stream loaded in 4 qualities, and come on, yeah, streaming. It is not downloaded. No, we haven't downloaded. Our video is streaming via S3 AWS Amazon. Okay, 1 second, why I'm doing this? So just go back here. I'm getting via Redis cache. If expired, if removed, then our S3 generates the new streaming URL buckets, and this is what, and encoded, and this, and all the qualities contains my chunks which is getting streamed. So till 0 to 10 seconds, okay, here the first chunk, and till we reach here the second chunk gets downloaded. See, streaming. We have built the Netflix. Congratulations. Okay, fine. So a big achievement. Okay, now our this what our project Netflix application is ready for the production. Yeah, you can use it. Okay, you can just allow other users to stream their movies on our this player platform, and viewers can watch just like doing in the Netflix. Okay, congratulations. Fine, so this is what about the video. If you like the video, then please subscribe my channel, subscribe, like, share. Okay, so our project Uber is done, the previous project. This Netflix is done. Now the third is again another big project is coming soon. Fine, okay, enjoyed. Yeah, so see you guys in the next video, and till then, thank you.